problems on their own. So without much ado, let us proceed. I'd like to first introduce our esteemed guests. Right now, we have Raghunath Iyer here, who is an IIT Bombay alumnus. He's a veteran from industry. He's built products like starting with printers and monitors and typewriters when he used to have a stint in Godrej. And then he worked for Qualys uh, 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 networks in Pune, which was a network security company. They used to actually build network switches which were used in stock exchanges and all that type of stuff. So he's got 35 years experience and he's a specialist in network security for many of these years. So he's built on-premise security appliances which are uh, managed by software as a service on the cloud, right? So apart from all these things, he's a very, very passionate tinkerer. He opens up all sorts of household gadgets and things like that, from phones to dishwashers, and he loves music and photography, travel, and all that type of stuff. But most of all, we've been really happy to have him around because he represents the quintessential engineer to us at e-Yantra. So the next person I'd like to, welcome Raghunath, take a bow, and we'd like to appreciate you being here. The next is Professor Partha Pandit, who's just been here for a brief while at IIT Bombay. He's a faculty member at the Center for Machine Intelligence and Data Science called C-Minds at IIT Bombay. And he's a BTech and MTech from IIT Bombay itself, and a PhD in ECE and MS in Statistics from UCLA. And generally, his area is machine learning, formally the generalization behavior of interpolating machine learning, whatever that means. So he's a specialist in things like neural networks, kernel machines. And if you are deep into AI, you'll know what all these things are. So he trains algorithms for large scale kernel machines. So let's say that his job is to make AI more accessible and faster, if you like. And he recently received an award, the AI 2050 Early Career Fellowship from Schmidt Science, which is a very prestigious award, and it came with a fair amount of money, I think in the hundreds of thousands of dollars, right? If I remember right, Partha, correct me if I'm wrong. So these are the two people. Am I right?
Yeah, that's right. Yeah.
Exactly how much?
It's 300,000.
300,000. Sorry. So great. 300,000, not rupees, dollars, which is a pretty cool achievement. So great to have you here with us. We have here Paritosh Pandya, who's a colleague of mine. I think he's here. Has he joined yet? Prem Kumar?
No, sir, he has not joined it.
But I'll introduce him anyway. He's computer scientists from the world of formal methods, so logic and automata, and the mathematics of program construction and so on. And he's a former professor and dean of the School of Technology and Computer Science at the TIFR, Tata Institute of Fundamental Research in Bombay, where he's worked as a researcher for a large number of years. So he's also passionate, although he's a formalist, where he works on formal methods. His passion is to work with e-Yantra because he likes to use that formal methods to actually make robots work, and he's trying to help us in the research aspects of what we do. We have a professor, Shubha Pandit, also I can see here. She is the former principal of KJ Somaya College in Bombay, very distinguished person who also works with us at e-Yantra as an advisor. So this is her first stint as part of the school robotics competition, and we are delighted to showcase to her what is happening in this space. So without much ado, I'll hand the floor over to my colleague in Chennai, Prem Kumar and Agnel. So over to you. I think you've got a short presentation which you'll share, which maps out the competition. And remember, guys, I'd like to tell the students here, we are not going to put you on the mat, right? This is not to kind of terrorize you. It's not an exam. We want to appreciate what you guys have done, because I think what you've done is very, very creditable and admirable that you've done this along with your schoolwork. And I'm sure our friends here, my colleagues, would like to know the background of your engaging with us in e-Yantra and what you felt this way of learning was compared to how you normally learn stuff. So over to you guys, Prem and Agnel.
Okay. Thank you so much, sir, for the introduction, and we welcome everybody, our
Sorry,
jury
I'd like to
members.
interrupt. Deepa Avudiyappan
Yes.
is leading the school initiative. I didn't realize that she's here because she has other commitments at the moment, but she's here with us. Thanks for that. So over to you, Deepa.
Oh, thank you, sir. Thank you, sir, for the introduction. And we will start. We will not wait. So we welcome everybody, our top 14 finalists who have done all the tasks and done everything so well that they are here. And we congratulate them. Now we request Ashish to share the main presentation about this competition. So we started this competition in October first week, and it was supposed to be a 3 months competition, but then considering exams and everything, we have made it 4 months, and now we are in the finals. So we had about 308 participants who were there with us from India, Bhutan, Qatar, and Dubai. And out of those 308 participants, there are 21 participants which are in top 14 teams who will be with us interacting with our jury members today. So all the best teams. Now I request Ashish to share about the Intrepid Explorer theme. Yes.
Yeah. Okay, just a second, I'll share my screen. Believe I need to get the access.
Yeah, sure. Just 1 second.
Sure. I believe my screen is visible, right?
Yes, Ashish.
Yeah. So e-Yantra School Robotics Competition hosts a theme that is Intrepid Explorer, which basically aims to teach students from class 7th to 12th the concepts in embedded systems and robotics. Students learn a lot of concepts starting from the very basics of robotics and implementing all of them in a creative and innovative way in the final theme, which includes them implementing a controller which makes the robot follow the wall, followed by another half of the arena, which includes a line follower. The entire point of the theme is for them to find an innovative solution to be able to switch from the wall follower to the line follower. Let me play a video showcasing the entire theme. So the entire theme ran for about 12 weeks, starting from the very basics, that is from Python programming to understanding what robots do, what a differential drive robot is, what controllers are, and how to implement a closed loop controller, a proportional controller, to allow the robot to move. Let's look at this and look at this entire journey in about 10 minutes. First, let me go ahead and play a video showcasing the entirety of the program that is starting from all of the tasks. Yeah. So the journey was an entirety of 12 weeks. So it includes students learning the basic concepts, starting from the very basics of programming to implementing controllers, to understanding how what differential drive robots are, implementing the proportional controller to help the robot move seamlessly through the arena, and finally traverse the final theme, that is the wall plus the line follower. Let's go through this entire journey of 12 weeks in a matter of 10 minutes. First, let me go ahead and play a video that showcases the entire theme, starting from the task 0, all until the final theme. In brief, the entire journey of 12 weeks consisted of the students starting off from programming a keyboard controller that is controlling the robot using the keyboards, using the keys on the keyboard, then integrating it with the sensors, then automating the process of movement, um, allow teaching the robot how to find out how obstacles are present in front of it using the distance sensors. Then moving on to ground sensors, noticing the line and using both of them to finally traverse the final theme, that is the final arena, which consists of the wall and line follower. So these are some of the statistics regarding the task submission all over from the first task to the final one. The yellow one representing all the team submissions, while it's split up into individual participants who took on the entire competition alone. And also the team participants are also mentioned in the form of a graph. Another interesting part of the competition was the teaching method. We held online teaching sessions every week so that the students could keep on par with learning and attempting the problem at the same time. Students were engaging very well and were asking innovative questions, which even helped us ponder and come up with new ideas all throughout this journey. These are some of the statistics for the feedbacks that we received from the students. Followed by the discussion forum. This is where the students kept asking questions where they kind of struggled, so they wanted to find out a solution. So the discussion forum was enabled for the students for them to be able to approach a solution, or maybe ask even the instructors how to approach a problem, or maybe even interact with the uh, instructors on whether their approach is right, or if that approach can be corrected or maybe improvised in some way or another. So we have a total of 14 teams that have reached the finals. The 14 teams will be split in between two distinguished juries. The first jury consisting of Professor Paritosh Pandya, Professor Parthe Pandit, and Mr. Raghunath Iyer. So I hope all the teams are ready, and see to it that your internet connection is stable. So these will be the 7 teams which will be going on in the first jury, followed by a second jury, which consists of Professor Paritosh Pandya, Dr. Madhura, Dr. Madhura ma'am, and Mr. Raghunath Iyer. So all the best to all of the teams. Do your presentation well. You've come a long way in this journey. So I hope all of you do well. All the best. Now I'd like to request Professor Kavyarya sir, the principal investigator of e-Yantra, to introduce the jury to the students. Thank you. Over to you, sir.
Hi, Ashish. I think I've introduced the jury enough, so we can go on to the next leg.
Sure.
Okay, so we'll move on to the actual session. So we'll be calling the teams that will be doing the presentation. So I'll share the screen, present the video. Then there will be a 5-minute Viva session with the jury members. Fine, right? So I'll call upon the first team. Select Samuel, team ID 4805 of from Amber International School, Thane. Right? I'll share the video now. One sec.
Lok, have you taken part in any e-Yantra competitions before?
No, sir, this is my first time.
Okay.
I'll play the video.
Hi, my name is Shlok Samay and my ID is 4805. I am in 7th standard and my school is Amber International School. Let's run the program while I explain the code. My code is divided into 4 parts. In the first part, I have initialized all the values of time step and max speed. The kp is the constant proportional. The small kp denotes wall falling and the large kp denotes line falling. In the next part of my code, I have enabled all the ground sensor and proximity sensor values. We will be using ground sensor 0, 1 and 2 for line following and proximity sensor 6 for wall following. In the third part of my code, I've used the Python function of def to define the two codes of wall following and line following. Here, the robot calculates the error by the given distance and reacts to it. In the line following code, the robot adjusts the values based on the values which are given by these two ground sensors and adjusts itself to the line. In the last in and this if elif statement is for the hinge joint error in vbots. In the last part of my code, it is the transition code. If the value is nothing but the color value, the black line denotes 30 and white color denotes 72. So if the value is greater than 60, it will stay in wall falling mode, and if the value is lesser than 60, it will stay in line falling mode. So I did a lot of things to optimize this code. First, in here, I tried keeping the value 100 and 120, but the robot either crashed into the wall, so I had to keep it 140. Also here, I tried keeping the value 40, 50, 75 and so on, but the robot didn't either catch the line here or completed the arena and left the line at this point or some other point. So this is my whole code. Thank you.
Right, Raghunath, would you like to start?
Yeah, I mean, Shlok, where did you learn Python first?
Like Python was partially introduced in sixth standard when I was in school, so but I didn't know a lot much of it, so it was just partially introduced.
And who gave the organization that you must have these functions and so on? Who gave you
Sorry?
that? The fact that you organized your code as X, I saw three functions being defined. So who
Yeah,
gave you
yeah.
that organization?
Uh, So actually, I used a lot of transitions but the robot wasn't catching it. Like it wasn't catching it. Stayed in line following mode. So I had to define those functions myself. Like I went to the Python basics and I found that define and so on.
Okay.
And sir,
And
one more thing, sir. Like uh, in those sprint values, I also found out that even in the line following mode in the console, it was showing wall follower. So that helped me find out that how to transition it. So I use the def functions.
Hey, Raghu, it'll be nice to see you.
sorry. Yeah. So, how did you test this? I mean, in what environment could you test this? Is this a virtual test or a real test with a robo on a physical terrain or physical obstacle course? I'm asking this to the e-Yantra folks because I cannot make that out. So was
No,
this
this was
all
done in a simulator.
this is
Yeah, so
done
we
in a
got
simulator?
simulator.
You got a simulator. So
Yeah.
you could try as many runs as you wanted, right, Shlok?
Yeah, like with the rewind button, like if there was any mistake, I could do as many runs I wanted and fix the code there.
So can you tell me approximately how many iterations did you try before you got to where you are right now?
At least average on 5 to 6 before I found out the error. Like,
Okay. And did you use sprints in between for helping you understand what the code is doing, or you just looked at the final results? How did you figure out that your program is working right, other than looking at the fact that the robo is not moving correctly?
like the print function from Python or the hard copy print function from Python, right?
Yeah, what did you do to figure out that your program is working when it, or to figure out where it was not working right when the robot did not do the job that it was intended to do?
Yeah, so I was when in the transition code, when the robot entered the line following arena, I figured that it wasn't really following the line. So I added the print, like if you in the console it appears, right? Wall falling mode and then the sensor values. And then I added the print and then they found out that when it entered the line falling arena, it didn't really change. It stayed in the wall falling mode. So print helped me figure out that if the robot was changing its mode from wall falling to line falling.
Okay, last question. Who else was there with you on this project? You were alone, or there were some other colleagues?
No, sir, my dad helped me with some parts.
And what does your dad do
My
in a
dad,
job?
my dad is an electrical engineer in Aker Solutions based in Norway.
Okay. Okay, that's all I have.
Yes, sir. Thank you.
Partha? Partha, one other question I have at the back of my mind, you should be asking yourself that, is if we were to train these kids in AI, first of all, could we, should we, and then how should we, how might we, right? That's a question I'd like you to keep at the back of your mind, because maybe that's another conversation that we'll have. Thanks. Go on.
Yeah. So Shlok, really nice effort. I really enjoyed checking this out. What were you given at the beginning? Like, were you given the entire code file, or were you given just a prompt to write this entire code by yourself, or what was provided to you when, along with the simulator, you must have received some code to
Yeah.
identify how the simulator works, and so what were you provided?
So I was provided with the basic code like all those max step, left get device and all. Only the transition code wasn't provided. I figured it out by myself, and the def functions weren't provided.
I see.
But the basic code was provided through the MD book, and I can say that for all tasks.
I see. I guess I had a question regarding the KP and capital KP values that you presented in your code.
Yeah.
Did you have to hard code them yourself, or were they initialized to some value when you were provided the code?
Sorry, sir, I didn't understand the
When you
question.
showed your code, right, there was something called KP, which are
Yeah.
proportional coefficients, one
Yeah.
for the line following mode and one for the wall following. Were you
Yeah.
provided these values along with the code that you had, or did you come up with the values yourself by experimenting?
No, the values were not provided to me, and the KP was also like the KP was provided in the task 3B and 4B proportional controllers, but the values were given by me.
I see. So how did you come up with the values? Can you describe what you did to
Uh,
come up with the values?
So like when I kept some value, the robot followed the arena, but once it came to a wall, for example, in the wall falling arena, once it came to the wall, it got stuck and it started oscillating a lot. So it was getting confused it was getting confused between the sensor readings and it was oscillating a lot. So I had to to stop those oscillations. I had to optimize the code, change those
Right.
values.
So now when you were seeing those oscillations, did you reduce the value of the corresponding K or increase the value of the corresponding K?
Uh, I tried both of them. Like I tried increasing them, I tried decreasing them, and the best value which I found between both of those, I kept it. So you could say I did both of them.
I see. Okay. Is that the only sort of failure mode you were seeing, oscillations? Was there anything else that you would see also in your experiments?
Uh, um, let me. Yeah, I think oscillation was the only thing.
Okay.
The other fact that it came too close to the walls, that was also one thing. It came too close to the walls at some point in KP.
I see.
But the
And
main
then,
factor was oscillations.
I see. And now once you change this, how much was the deviation from the center? Like would it go close to the wall at all, or would it just stay in the middle of the track?
Uh, at the turning, it would go like little bit close, not dangerously close. And then after it made the turn, it will come to the center.
I see. Okay. I guess last question. So
Yeah.
have you actually seen the hardware for a wall follower ever before?
Hardware in the sense.
Like a physical robot which does wall
Mm,
following?
no,
I see.
no.
Okay. Yeah, okay. That's all my
Okay.
questions for today.
Thank you.
Thanks so much. Yeah.
Partha, that's a good question. In fact, we had intended that after the simulation phase, we'll actually give them hardware in their hand, but it didn't happen in this round. What we do in our college competition is that we run it in 2 stages. The first stage is inside a simulator. So everybody cracks a problem first in a simulator. And then the 20% who've done well, we actually give them hardware at our cost. Right. So that's the model of e-Yantra competitions. But in the school case, we are first exploring and getting the kids used to actually doing the programming first. So this is more a programming kind of training at the moment. The next step will be with actual hardware. So one more thing, Shlok, I noticed that when you changed mode from wall following to line following, the robot went off the line. So you had to discover the line again. How did you do it?
That was one problem which I couldn't figure a solution for. Actually, when the robot reached that point of the arena, it couldn't just keep itself in the center. It like went away from the center, and then it couldn't catch the line at the beginning. So, but it had to then catch the line. So that was one problem. I also tried for it, but the solution was not being able to found. Like the robot either crashed
Did you
somewhere.
did you ever have a problem where it kind of drifts off and then it can't find the line again? Because it might just go over the line but not know that it's on the line and keep on going and hitting the other side or going off on the arena. Did that also happen?
So I would like to highlight one problem here. Just like the earlier scenario, the robot didn't catch the line, but as it takes a turn to catch the line, right, in the
Hmm.
video.
Hmm.
So in that case, it didn't catch the line and hit the border line of the line following arena. So that was one problem.
Okay. So I'm sure that you've learned a few things without realizing it here on this thing. So it'll be interesting to see what the jury has to say at the end. Thank you very
Yeah.
much. Thank you.
Thank you.
Thank you, Shlok. So we'll move on to the next participant. So
So are we
Kash,
on time or are we taking too long per participant?
it's a bit too long, sir. So it's going around 7 to 8 minutes. So
And how much should it be?
5 minutes.
5 minutes. Okay, fine.
Yeah.
Thanks.
So we'll move on to the next participant. So Kashvi Jain, 3667 of JD Goneka Public School, Jammu and Kashmir. Okay, I'll share the video now.
Hi, I'm Kashmir Jain from Team ID 3667. I'm from GT Goenka Public School Jammu and I'm currently studying in 8th standard. Welcome to the final task output video. Let's run the simulation. To run the epoch, I studied the arena in detail and tried to understand the ground and the proximity sensors values at different points in the arena. I explored various what-if logics and consequently designed the code logic. Now let's try to understand the code written to make the epoch traverse the given path. Firstly, we're initializing the variables and setting up the epoch along with the ground and the proximity sensors. The path variable can have two values, W, which refers to wall following, and L, which refers to line following. Next, we make the necessary calculations based on the value of the path variable. The v variable refers to the forward velocity of the epoch. We set the left motor's velocity to v plus w and the right motor's velocity to v minus w. If the velocity calculated exceeds the maximum velocity of epoch, which is 6.28 radians per second, then we set the motor's velocity to the max speed. Lastly, based on the values of the GS and the PS sensors, we set the value of the path variable. I've used the proportional controller to calculate the left and the right motor velocities. So, to optimize the code, I figured out the best fitted KP and the forward velocity value by using different what-if scenarios with various KP and forward velocity values. Overall, the design code makes the epoch navigate accurately within the arena, as shown in the robot window. Thank you.
So we'll move on to the jury. Paritosh sir is there? Paritosh sir, please.
Hello, can you hear me?
Yes, sir.
We can, but we
Okay.
can't see you.
No, my camera is broken. Please,
Acha,
you'll
okay.
have to excuse me.
Fine,
Yeah.
fine.
All right. So, yeah, nice effort. I could see your solution going nicely. I had a question about, when you are doing line following, there are some places where you come to a rectangular turn, right?
Yes, sir.
How did you handle that? Did you have to do something special to handle it as compared to normal line following?
No, sir. Actually, this was proportional controllers, so
Yes.
it's all the magic of the KP value. I
Yes.
figured out the best fitted KP value, which was suitable for both the curvy paths as well as the straight paths. So that's the way it worked.
No, straight path is fine. When you've got a rectangular turn, a 90-degree turn, then how does your controller work? Do you anticipate any problems there? I saw your robot stop there for a moment.
Oh, no, no. It didn't stop, but it was like taking the 90-degree turn. It was taking some time to take the turn. And for that, I figured out the KP value. I don't know how many times. I think I spent an hour or so figuring out the best fitted KP value. I iterated through various KP values. When there's less KP value, then the robot doesn't react really harshly. So that slows down its motion. Whereas if we keep the KP value high, it makes more oscillations, thereby taking like making abrupt changes. So
Right.
we needed a sweet point between the KP values. So I iterated through them all and figured out the best one.
Okay, thank you. Next.
Actually, I had the same question. I saw that the robo paused at the sharp corner, and I was wondering what's going on. So it slowed down significantly. But I also noticed at some points where in the curvilinear path or somewhat the straight path, it was not necessarily in the middle. It was getting closer to the wall. So in the early part, do you have anything to say about why it was getting closer to the wall? For example, if it's making a curve like this, right? So it'll go closer to the wall here, and then when it comes out, it'll go closer to the other wall and then get into the middle.
Like that was also the problem with the KP value. If you see that the arena was not specifically straight or either curvy, so it was, in between, it was taking a little sharp turns, and then that's the reason it deviated from the path. But if I changed the KP value, then it was stucking near those 90-degree turns. It ended up crashing itself into the wall. So I had to keep the KP value like that. Otherwise, it didn't work.
Okay. So apart from playing around with KP values, did you have any other contribution to the code, or did you make any changes to the program? What did you have to do with the code?
So firstly, when I approached the task, I was in a little bit of hurry. So I, created a logic that was the logic when I had created like 3 paths: wall following, line following, and the transition period. So I had written different codes for all those things. But the problem that was coming was that near that tunnel, the transition period between wall and line following, it was moving towards the wall. Then when it came out from the tunnel, it was again getting onto the line. That was the issue. So then I changed the logic. I thought about what exactly was happening. I printed out the sensor values, the GS, which are the ground sensors, and the PA sensor values, which are the proximity sensors. I printed out those values. I understood what the problem was. Then I changed the code and only limited it to two things, which is wall following and line following, and also wrote the conditions after taking into consideration the sensor values at different points in the arena. Then I wrote the conditions,
Okay.
and that's the way it worked.
So before this project, where have, have you had any prior introduction to Python?
Oh, yes, sir. I had actually done a specialization of Python, which consisted of 5 Python courses by the University of Michigan. I had taken around 1 full year to learn Python programming, and after that, the specialization only I participated in this competition.
Okay. Who else was helping you apart from e-Yantra people?
I was an individual participant, so I worked out on this project on my own. But for the first task, there were a few formulae, math formulae. I was not able to understand them well. So for that, my mother helped. But for the coding part, I did it on my own.
And what does your mother do?
She's a computer science assistant professor at Government Degree College, Samba.
Which place? Location?
Government Degree College, Samba.
Samba. Where is that?
It's near Jammu only, but it's
Near Jammu.
on the outer side.
Okay. Okay. Okay.
Yeah, Raghu, I think we are going through the motions of setting up an e-Yantra lab at the Government Engineering College there.
Yeah, I'm trying to, I'm also trying to understand the background profile of the competitors. That's
Yes,
also an important element in how you evaluate and what experience they have had prior to this.
indeed. But it's quite interesting that, Kashvi, you've said that you've taken this course from the University of Michigan. Was it
Michigan.
a Coursera course or was it something
Huh.
else? A
Coursera
Coursera course.
specialization.
I see. And was it meant for any age group or was it meant for school children or what?
No, actually, it's a professional course only, like based on for professionals. But like there's no age limit or something like that. So anybody who's curious and can participate, he or she can participate after giving the required fees.
Okay.
So who introduced you to that course?
My mother. And during the COVID times, there was this huge, advertisement and all of these coding thing. Everybody, you know, there was a lot of advertisement. So my mother searched about what exactly, like it came into the market. So my mother searched about it. So I started off in fifth grade, fourth or fifth grade. I started with Scratch programming, that simple programming, block-based programming. I did one course for that. I participated in competitions. I became more curious and more inspired and motivated to take part in more such courses. So my mother
Okay.
then searched for Python because Python is one of the easiest languages. So she gave me the access to that course, the 5 courses. I did them, and also now I'm currently doing C programming.
Okay. Interesting. Thank you. That's all I have.
Thank you. Partha, anything to say?
No,
Okay.
a very
So
nice
We
work.
would
Yeah.
also we would also like to highlight Kashvi participated in virtual museum competition with us. So she was a winner there. And then next edition was Intrepid Explorer. So here also. Yeah, Agnel.
Okay, good. So one thing I'd like to know, Kashvi, is do your friends at school know that you've been taking part in these competitions and so on?
Like last time I was in the virtual music competition, so at that time I had told them, but they didn't seem interested. They thought of it to be something more or so related to computers only. And in our school, I hardly see any people, taking interest in computer programming. Neither do the teachers take interest. So I have told them, I have told my computer teacher to see if any other participant is interested, and he or she can form a team with me, but no response.
So what do they regard you as, a bit of a nerd in class or what?
Yeah.
Okay, thanks. We can move on.
Okay. Thank you, Kashvi. So we'll move on to the next team. 468, Adityan Ranjit, Ryan Cherian Jacob, Navneet Anil Karta from the Choice School, Ernakulam. I'll share the video now.
It'll be nice if you make the video a little fast, because I think the jury will get the idea anyway. If the guys don't mind, your voice will sound a bit different, but if you do it at 1.25 speed, then let's see how it sounds.
Yes, sir. Sure, sir.
Good afternoon, everyone, and we are at Team 468 at Choice School, Kochi. I'm Ryan Cherian Jacob, and with me is Arjun Alvi and Navneet Nanal Kalta. We are grade 10 students at the Choice School, Kochi. Moving on with the code, the first part involves importing the various libraries, initializing the robot, motors, as well as its sensors, and defining various important variables like the linear velocity, basic time step, two proportionality constants, a flag variable for switching between line following as well as wall following, and a proximity sensor variable along with three ground sensor variables.
The next part of the code shows the algorithms and conditions we used for both wall following and line following using a proportional control algorithm. We used a while loop and certain commands to continuously obtain the values of both the ground and front right proximity sensors. Here we have the wall following algorithm. Distance represents the current distance from the wall. Set distance is the desired distance to maintain from the wall, and error is the difference between distance and set distance. Finally, U is the correction required based on the error, scaled by the proportionality constant Kp. The first conditional prevents the overshooting of U, while the second conditional ensures the variable velocity stay within the epoch's limits while maintaining optimal speed. Signs are adjusted based on U to ensure correct correction direction. When U is greater than 0, the robot is too far from the wall and thus turns right, while when U is less than 0, it turns left.
Now let's move on to the line following algorithm of our code. As you can see, GSV greater than 0 shows whether the ground sensors detect something or not, and GSV less than 40 shows whether the ground sensor values are relatively low to ensure the detection of a black line in a white background. Now the flag system is used to ensure the continuous use of the line following algorithm even when the ground sensors don't detect a black line. The error is used to determine the difference between the right and left sensor values, and it shows how far off center the robot is with respect to the black line. Finally, we have U, which is the correction required by the robot with respect to the error and the KP provided. The final part of the code is essentially similar to that of the wall following algorithm, and it's pretty simple and easy to understand. However, U less than 0 over here means that the robot veers to the right, and U greater than 0 over here means that the robot veers to the left. That's all for our code and demonstration, and we hope you have a wonderful day ahead. Thank you for this amazing opportunity, and this is Team 468 signing off.
Thank you.
Was there a demo? We didn't see the demo.
It's on the left-hand screen, sir.
Oh,
The
no.
side.
Oh, wow. We didn't see that. I didn't pay attention to that. Sorry.
We'll start with Pandey. Sir.
Yeah, hi. So I have a question. You guys were using something called PS1. What was PS1?
So that is the proximity sensor that we used, which is on the right-hand side of the epoch robot.
I see. So what was the type of this variable that you were using? Like,
It's basically a proximity sensor that detects data on whether how far from the wall the robot is. So the actual
you
data
had
is inverse.
some lines in your code which said PS1 type dot something, right? What was happening there exactly, sort of?
So in the first part of the code, we had the initialization of PS1, which was robot.getDevice PS1, then enable the time step so that it continuously works. Then we used PS1.getValue and we added that to a variable called PSValue1.
So PS1 is some type of an object, is it?
No, sir, it's a sensor. It's a sensor in the epoch which is used to detect how far off the robot is from the wall.
Right. And then in the sensor readings that you had, there was something called dist equal to 255 minus PS1 dot get value or something like that. Do you remember
Yes.
something like this?
Yes, sir. So
So what is this 255? Like,
that's the maximum value that is being obtained by the proximity sensor.
right, but is this some kind of like, does it take negative values also, or does it only take
No,
positive
sir. It's
values?
between 0 to 255.
I see. And
And that value, we are inversing it and comparing it with respect to our set distance, which is 152.
I see. And these are all integers, right?
Yes, sir.
So why is it better to work with integers rather than floating point numbers? Are you familiar with floating point numbers?
Yes, sir.
Why is it better to work with integers and not floating points?
I mean, personally, so I believe it's easier for calculations and it makes complex data much more simpler. But other than that, it may also take a lot of time in the case of a compiler, it might take a bit more time to compile that code and convert it. So other than that, I don't think there is any advantage.
Okay. By the way, is your code compiled before it runs on this simulator, or is
No,
this
sir.
just
This
like
is
an
a Python
interpreted?
code. Python code. It's interpreted.
Yeah, no further questions.
Raghunath sir.
Sorry, I was muted. Yeah. So again, usual question. What class are you in? Where did you learn Python before?
We are all studying in the same school, grade 10. We learned Python I learned Python in the after school program.
Hey, your voice is like echoing. I'm not able to make out whether others are also having hearing difficulty. I find the
Yeah,
voice
I'm
is very
also having the
muffled.
same echo. I can't hear him
Other
properly.
candidates' voice was very clear.
I'm sorry, sir. Is it okay now?
No, it's still sounding as if it's coming from a tunnel.
Alright, sir. Maybe another candidate can speak while I figure out my issue.
Well, so I think Ryan is having some technical difficulties. Basically, all three of us are from the same school. We are studying in the Choice School, Kochi, Kerala, and we are studying in grade 10. And I personally learned Python in grade 6 from Udemy. I did a course on Python. And I also learned various other programming languages from my school: HTML, CSS, JavaScript, Java, a bit of PHP, and SQL.
Okay.
Yeah, yes.
Yeah,
As Navneet
I
pointed
see.
out.
I see the code structure is quite different from what others have shown so far. What changed? How did this happen? I mean, am I see? Did I miss something?
No,
This
sir.
is to e-Yantra folks.
Uh, Basically, in the given code, in the code that was given in the MD book, there were a couple of issues that we faced. First thing was the error value which we obtained when multiplied with the proportionality constant gave a greater value than 6.28. We knew that the maximum velocity of the robot can be 6.28 radian per second. And this value was greater than 6.28 and it went up to 8 or 9 radian per second. This means that the robot wheels practically exploded at that point and it wouldn't move. So to combat this issue, we basically edited our KP values and we also made sure that we have a better angular velocity equation wherein the u which
Oh,
we
okay.
obtain.
1 minute. You're going into the details of the micro details. I'm talking of higher level code structure. I thought I saw a different code structure. Yeah, and this was not the code structure that I saw with other folks.
Yes, sir.
Egnell,
Yeah, sir. We gave only a boilerplate code, sir. So which
ah,
was a very basic code, which will get them started. So they were free to
okay.
edit the code however they want to their wish. And the 6.28 issue you split, right? That was kept it intentionally so that students should understand.
Yeah, so Agnel, the next question is, I mean, did I read it correctly that these people's code had slightly different structure itself, or
Yes, sir.
they had used the boilerplate as is.
No, they have changed the boilerplate.
They have changed the boilerplate, right?
They have created on their own a bit.
Yeah, that's what I saw. So I just
Yeah.
wanted to make sure that I'm seeing it right.
Yes,
And I
sir.
didn't miss because the speed at which it went, I could not comprehend
Yes, sir.
some parts. So, okay. I mean, because if that boilerplate is being changed, then obviously there is a lot more work that has gone in the background before they arrived at whatever they did.
Yes, sir.
Okay. I don't have more questions than that.
Okay, sir. Thank you so much.
Thank you.
Thanks. We can move on.
Okay, sir. So we'll move on to the next team.
First, how are we doing for time? How long will we take?
This is fine, sir, but little more short will be fine.
Okay, we'll do.
So we'll move on to the next team, 480, Tanmaya Alkani and Tamana Alkani of Delhi Public School. So I'll share the video now.
Hello everyone, this is Tamanna and myself Tanmaya of Team ID 480 of Grade 7 from DPS Paradeep Refinery School. We're very much privileged to be a part of this e-Yantra School Robotics Competition 2024. Coming to this task, here we were given a path where the epoch has to follow the wall in the first half of the arena and then it should follow the line in the second half of the arena. So in the beginning, we have initialized the motors, the proximity sensors, and then the ground sensors. So for the epoch to follow this wall, we have initialized the PS6 sensor, and for the epoch to follow this line, we have initialized all the 3 GS sensors. Now let me explain by starting the simulation. As you can see, the epoch is following the wall along its path, and once it reaches this point, it will switch from the wall follower to the line follower code. And to switch between wall follower to the line follower, we have used a simple if-else statement where we have created a variable called a. In this variable a, we have stored the addition of the 3 GS values, and according to this condition, the epoch will change its code from wall follower to the line follower. Since this path is not straight, we have adjusted the velocities of the right wheel and the left wheel of the epoch using this proportional constant. So we have got this value of the proportional constant by using the trial and error method, which we continued until we got the perfect proportional gain constant value. So by adjusting this proportional constant value, the epoch also started to move much more faster without colliding with the wall. So here, as you can see, that the epoch is not colliding with the wall and is following the line perfectly. Now, as you can see, that the epoch is reaching its final destination without colliding any wall. Thank you.
Rangnath, sir, please.
Yeah. So, most interesting, I saw the wall follower was, I mean, firstly, congratulations. I mean, you guys have done well to do this
Thank you,
job.
sir.
But I saw that the wall follower implementation behaved poorly, whereas the line follower was really accurate.
Yes,
So
sir.
wall follower had a tendency, and I noticed one more behavior in the wall follower. It was when making turns, on one direction it used to be going too close to the wall, whereas in the other case it used to be far away from the wall and make turns. So I saw both behaviors. It's either too close or it's too far. You want to make any comment as to why that would be the case?
Sir, it's actually just because of the proportional gain constant. We kept on adjusting it using the trial and error method, but we couldn't, we just got that KP value which we have shown in the code as the perfect one. So we just kept that.
Yeah, I mean, but there must be some explanation of the behavior that you have figured out afterwards. You have any insight on that? I mean, when you experimented, obviously you must have seen that if I increase the value, this happens. If I did this, it behaves this way. Do you have any comments to make on that?
Sir, actually,
if we increase the KP value, then it is colliding with the wall, or it is going extremely close to the wall. So we decided to decrease the KP value. So it was going a bit better, but it was still going close. So we couldn't figure out the solution to that.
Which grade are you?
Sir, 7th.
7th grade. And again, I saw changes in the code structure. Is that true, Agnel?
So this was the boilerplate that was given, kind of.
Okay.
And they are
Okay.
free to changes over they
Yeah,
want.
okay.
But
Okay. And where did you learn Python before this?
Sir,
This is to Tamanna.
Python was actually partially taught to us in school in this year only. So we got to learn more about the if-else statement. So we just use that in our code.
So this is DPS school in Orissa.
Yes, sir.
DPS is Delhi Public School?
Yes, sir.
Okay. I have no further question.
Thank you, sir.
but sir, yeah, Auntie sir.
Okay, congratulations to you for completing the project nicely. I think in 7th standard, it is very heartening to see that you are able to code solutions like this. Now, I have a question going a little bit beyond what you have done. Okay. So we are
Okay,
just
sir.
discussing. We are just discussing. Your solution is fine. Here in the VBOT simulation, you are given some value of the proximity sensor, which you use to follow the wall, right?
Yes, sir.
Now, being a simulator, it gives you perfect value of that distance from the wall. Okay.
Yes, sir.
But in real life, what happens is these sensors are imperfect. Also, walls are not very perfect. They will have color which will affect the distance. So you will get slightly unreliable reading of the distance from the wall.
Yes, sir.
Huh? Not all readings, but little bit errors can crop in once in a while. How do you think we should handle this in your design? If you have to modify so that you make it noise proof, error proof. Any thoughts? I'm asking something beyond what you did.
Sir, no such thoughts.
Now, what could we do? We are getting some 3 readings and some of them may have some errors which are occurring randomly.
Sir, we can take more feedback.
Feedback of what?
Sir, feedback of the sensors of the epoch.
What do you mean by feedback of the sensor? More readings of the sensor.
Yes, sir.
So you take multiple readings and then what do you do with this set of readings?
Sir, we can adjust that according to the path.
Any thoughts on how you will do this adjustment? Suppose you take 3 readings of the proximity center. Now, what will you do to those values?
Sir, we can adjust the distance and we can also adjust the sensor values. We can also adjust the readings of the sensors according to the arena and the path.
Okay. No, I think what you can do is suppose you take the average of the 3 readings. Instead, we can take more readings, right?
Yes, sir.
So if you average this sensor readings, do you think the average will be a better measure of how far you are from the wall?
Maybe yes, sir.
Yeah, think about it. Okay? Some thinking
Okay,
question.
sir.
Anyway, congrats again for doing the project nicely.
Thank you, sir.
Fateh sir.
Yeah, really cool. I actually really enjoyed that your wall follower was taking really sharp turns and going all the way to the wall, and that was sort of fun to watch. I was sitting at the edge of my seat, hoping that it wouldn't crash into the wall. I had one question. So, in your KP tuning, you had gone and tuned your KP value up to 5 decimal points. I remember a value of something like 0.15574.
Yes, sir.
Why did you go that deep into the tuning? Like, how many times did you tune? Did you start at five digits after zero, or did you start at 0.1 and then tell me how you tuned this? I'm curious.
Sir, actually, adjusting the KP value was a very big challenge. We tried it many times by using the trial and error method. So even if we reduce a bit of the decimal point, then it is either colliding with the wall or it is not going in a perfect, going according to the perfect path.
But then
So
was
we
it colliding
decided,
at the same place every time, or was it colliding at different places, or what was happening?
sir, at different places it is colliding.
Okay. So then is this one simulation that sort of completed, or like did you have multiple simulations that completed and it's just
Sir,
one of them that
multiple,
you, I see. Okay.
multiple.
But then when you were tuning them at like 0.15574, were they not working at 156 and 154, or like what was happening? Or did you not try these values?
Sir, we didn't try those values. We just did whatever was the best. So this value, the 5-digit decimal value it went well for our code also. So
Right. So
that's
I'm
why
curious, so what was the value that you tried before this value? So you succeeded at 0.15574. What was the value that you tried before this? Like was that, what did you come up with this value at random? Doesn't seem like it, because there was some gradation that you must have seen. But 5 values after
Sir,
decimal is a little surprising. That's why I'm curious.
sir, we tried many, starting from, actually we were given a range by the e-Yantra team to range our KP value between 0 to 2. So we just started from 0.1 and all like that, and we got the 0.15574, the best one.
All right. Okay. Thanks. Great effort.
Thank you, sir.
Thank you, guys. So we'll move on to the next team. 5361 Sudanma Kantur, BJS Public School, Bangalore.
How are we doing for time?
Same, sir. Yeah, just keeping up. It's around 7 to 8 minutes. It's fine.
So do you want us to take less time?
If yes,
Okay, we'll
if
do.
you can, it says.
Okay.
But I think students are enjoying it, so it's fine.
Sudhanva, we can't hear you.
Jai Shri Gurudev, sir. Am I audible?
Yes, now you're better. So where are you speaking from?
I'm speaking from Bangalore.
Okay, go on.
Sir, should I
One
explain
second, sir.
the...
I'll share the video. We are just trying to adjust the speed. Yeah.
Myself, Sudanva V. Kandur of Class 8, BGS Public School, Bangalore. My team ID.
I think it's making the voice a little bad. So 1 second.
Yeah, fine.
There is only option for 1.5 in media players, sir. That is why we're having this.
Yeah, go on, just play it.
Yeah, sure, sir.
Jai Shri Gurudev. Myself, Sudanva V. Kandur of Class 8, BGS Public School, Bangalore. My team ID is 5361. Today, I proudly present to you all the final task of Intrepid Explorer Edition 2, conducted by e-Yantra, IIT Bombay. So in this task, first we have to follow the wall, then detect the line, and finally track the line until the end of arena. We are using e-Pug, that is a differential drive robot. That is, it has 2 actuators. Actuators are the part which make the robot move, and the robot turns towards the actuator which has low velocity. Here I have initialized them. This is PS or proximity sensor. They say the different distance between the robot and the obstacle. Its value is inversely proportional to the distance. Next we have ground sensors. We have 3 ground sensors. Ground sensor 0, that is left one, JS1 in the middle, JS2 at the right. So here I have initialized them. They say how much light is reflected or the color that is below the bot. This is wall following. First I get the sensor value, then I subtract it from maximum sensor value, that is 255, so that the distance is inversely proportional to the to the value. And next we have set distance, that is the value to be maintained from the wall. Next we calculate the deflection or error by subtracting set distance from the distance or the current sensor value. Next we have omega, that is turning velocity. It is the degree of turn of the robot, and we calculate it by using the formula kp times error, that is where kp is proportional constant. Next we get the final wheel velocities, that is wl equals v plus w, and right velocity equals v minus w. Next I give it the speed towards its to its max speed, and then left I assign those values to the left to the motors. Next this is line following. Here I get the values by subtracting right sensor value from left sensor value. This is the error. Next I get the omega, and then I get the final wheel velocities. So lastly I limit them and then assign them to the motors. So the last block of code is the traverse between wall following and line following. I get this as black reflects less light than white, so that it gives a less value. I observe that it gives a value below 60. So whenever any of the ground sensors detect a value below 60, it changes into line following. Else it continues to follow the wall. You can see how good the robot is following the line. Thank you.
Fateh, sir.
Hey, quick question. So your visualization that you had in your video had these spokes coming out of your robot. What was that? Did you add this on your own, or?
No, sir, they are the like the proximity sensors in real how it will be. So
I
they are
see.
the
So
rays of it.
this is part of the simulation that is provided to you?
Yes, sir. So we just need to uh, initialize them in the settings.
I see. So this is by default, it's not turned on, but you have to turn it on, the
Yes, sir.
visualization. I see. Did you use this visualization during your experimentation? Do the color codes actually tell you some information?
Yes, sir. So the color code, the colored ray was the one which I was using.
I see. So were you changing which one to look at, or
No, sir. The whole simulation, that one only was used.
I see. Okay. Did you try playing with other sensors instead
Yes.
of the
So
one?
first I used the left side of it, and then I detected that it was while in the tunnel, it was not getting the current time of it. It was detecting the end of the tunnel. So I changed to right side, so it won't do that error.
Right. But you could have changed the active sensor, right? Like during the run as well. Or is that not something you can do?
Sir, we can't. I don't know how to detect where the robot is in the arena. So if I was able to do that, I would I could change this active sensors.
But you do have a code block that actually identifies whether you're in the wall following mode or the line following
Yes,
mode or
sir.
in the tunnel, right? So you kind
Yes,
of
sir.
have a good sense of where you are based on that
Yes,
that
sir.
part of your.
Sir, it just says what's under the robot, that part of code.
Right, but then you could have changed the sensor that's active in the wall following and in the line following. I'm curious why you
Sir, in
didn't
the line
change it.
following, that sensor isn't used. The other sensor, it's on the bottom of the robot.
Oh, right, that's correct. Okay,
Yes, sir.
yeah, my bad. Okay, great, nice, thanks.
Thank you, sir.
Raghunath, sir.
Yeah. Hi, Sadhanva. Nice implementation.
Thank you,
I'm
sir.
going to ask you a question that I wish I had asked the others also, and maybe we should have this afterwards. What will happen to your implementation if, without any change in the code, we start the epoch at the opposite end of this whole course, where line following comes first, and then tunnel comes, and then wall following has to happen? Will the whole implementation work correctly, or there'll be problems?
It can work correctly, as it's actually easier that at first only it will be detecting the line, but it should be on the line and not on the blue patch that's given. And then it comes into the white space, all the sensor values increase, and so it changes to wall following.
Okay, and if it's not on the line, it's a little off the line, what would happen?
So then there are
Will
three
it?
sensors. If any one of them is on the line, it will work correctly. If it's not on the line, if there are
How
very
does it
less
know that
chances.
it is? How does it know that it is in the line area and not in the wall area of the whole puzzle?
So as I said in the video, black reflects less light. So basically the robot's bottom sends three rays, light rays, and it measures how much of it is sent back. As black sends very less of it, it gives very less value.
And that is
So
used in
and
the
white
code
gives
to. And is that used in the code to detect that it's in wall following and line following area?
yes, sir.
Okay. Which grade are you in?
Eighth grade, sir.
You're in 8th grade. And who else helped you apart from e-Yantra folks?
I did not get much help, sir, but I got some moral support from my parents.
Okay. And where did you learn Python before this?
So like in the lockdown, I simply learned turtle graphics from Udemy as
Okay.
for me to get involved.
So lockdown is like 4 years back, right? Or 5 years, 4 years
Yes,
back.
sir. Yes,
Okay.
sir. And this year they're teaching it for us in the school.
Okay. That's all I have.
Thank you, sir.
That's interesting, Sudhanya. That means, Sudhanva, that you learned turtle graphics when you were in the 4th standard, is it?
Yes, sir.
Yeah.
Acha, interesting.
Yeah,
Good.
Scratch and all of these, I think, are taught. Scratch, turtle graphics, all of these are 3rd, 4th grade kind of activities.
Yeah. Good. Thanks.
They should go this, sir.
Thank
Agnel,
you.
you can go on.
Yes, ma'am. Thank you, sir. And thank you, Sudhanva. So we'll move on to the next team. Team number 513, Vaishnavi and Viraj Vinod of Vidya Kendran Convent School, Sindhudurg.
Hello.
Hi, my name is Vaishnavi Chirag Mandikar.
And my name is Viraj, and our team's name is Team Vidyanikatan Convent Kasal, team ID 513.
This is the video
Hey,
demonstration of the final
can you
task for
slow
the
it down, please? Please, it's too fast. We cannot keep up with this.
e-Yantra Intrepid Explorer competition.
So let's start the simulation. So as you can see, in the first half, the epoch is traveling the first stadium, which is the evolved one. So for this thing, I have written this code. So this is the basic setup of the epoch, and this is the main while loop for this part. So I have chose the PS1 sensor here, and let me stop here just for a second. So this inputs of the PS1 sensor, they have been given to the distance inverse, and this is the error calculation part, and this is the setting which I have done. So for this setting, for the turns, if the distance is too high, then it will increase the kp very much, but for the remaining stadium, it will keep the kp as 0.22. So this is the main modification which helps me in the turning part. So this is the modifications setting for keeping the max speed in control. And for breaking this, so let's start again. So for breaking this for this while loop here, I have given this code that if it senses a black line anywhere on these ground sensors, it will break this while loop. So after this, it will enter the next while loop. So these are the basic settings of the for giving the names to the ground sensor. This is my keeping value. This is my error calculation part. This kp value I got after many trials, because in first my epoch was stuck in here for a very long time, and after many trials I got this value, and this is the last this for keeping the max speed in control. So yes, this was our team score. Thank you so much.
Yeah. Paritosh, sir?
Yeah. So you work in these two modes, right? The wall following mode and then a line following mode, right?
Yes. Yes.
If you go out of the line while you are doing line following, would you use wall following?
No.
So you require a line
Because
following to keep you on the line all the time, right?
Yeah.
Maybe
Yeah.
you will be a little bit to the left or right, but you will be within the line following area. What happens if
Yeah.
the robot moves completely out of the line so that there is no line below the color sensors at the bottom?
Basically, it would not go, and if it goes, the I think it's like that that the middle means that there are three ground sensors
Yes.
which actually conceptually the black lines. So if the middle is not there, it will cannot so it will first the black line and then continue in this code I have done trials, so it will cannot go offline.
So you are assuming it will never go out of the black line completely, right?
Yeah.
Yeah. But suppose I had a very sharp turn, maybe 245-degree turn in the line,
Okay. Okay.
It could go out of the line. So then what would be a good strategy to come back to the line?
If it goes completely out of the line, then I guess if there is no wall or something, so we can't use the TF sensor also there. So that at that time, it would be difficult to get it.
But there are walls around you. There are walls
No,
around.
not in the line.
Oh, there are no walls around there. Okay.
Yeah.
But if you remember a little bit of the history, you know that you are drifting to the left of the line. You are going a little bit to the left. So even if you move completely out of the line, do you think you could use some sort of memory to come back to the line? Because you have some sort of knowledge from the past that, your line is somewhere to your right. You are drifting towards the left.
Okay. Then we can do the code just like that. There are three sets of sensors. So if the start turn is at left, so the left sensor would sense it and they keep it in its code, forward state, and then if it goes out of the line, then it can go. Means I can.
You're getting the idea, right?
Yeah.
Okay, thank you. I have no other question.
Yeah.
Raghunath, sir?
I guess I can step in.
Yeah, sure.
Yeah, okay. I saw a condition that if distance is less than 80, you have a different value for KP, and if distance is greater than 80, you have a different value for KP. why did you decide to have different values? Like, what was the intuition you had?
That is for the advanced spots for the sensors. Means these sensors, they are at somewhat this angle from the epoch. So if there are turns which are like that, so then at some point the value will drop at a particular. So for that point only, for the term only, the KP, if it is too high, means from 0.2 to 0.6, then it will make a good trade. Means,
Okay. Yeah, no more questions. Thanks.
My question was along the same lines as what you asked, and it was a little more broader question. So this implementation used different KP values, but on a larger question, is it only two KP values that you can work with? Can you have more KP values depending on what's happening on a step-by-step basis?
yes, in this code, I have worked with two KP values, so three KP values, two in the wall following and one in the assignment. So, why should we keep this three we can keep more kind of views, we don't too sure. Then if for the KPs too high, then it would be good for taking smart turns. But in the general one, in the state manufacturer, the normal for 0.21 is makes it one above.
Very hard to make out. I'm sorry. It's really difficult to follow because of the audio. Could you guys follow all of it? I followed some of it.
I couldn't hear
It wasn't the clearest.
Yeah. Okay. My next question, which is I asked all candidates, what grade are you in?
11th standard.
Pardon?
11th standard.
11.
11th standard. Yeah.
Okay.
And the young lady's 10th.
Yeah, I heard that. Okay. And which grade did you learn Python in?
I I learned in 8th grade.
8th grade.
Yeah. And
Okay.
she
And
learned just tomorrow.
sorry, can she speak?
After participating in the competition.
Hey
So
guys, can you make?
how did you
Yes,
split the
sir.
work between yourselves?
She learned the Python in this competition only.
Oh, okay.
Okay.
Okay, I don't have
Enough.
more questions right now.
Should we move on?
Yeah.
Okay.
Thank you.
Thank you so much.
Thank you. Thank you, team. So we'll move on to the last member of the first session. So team 1080, we need Bhojanpur, St. Mira's High School, Bangalore.
Yeah, hello. Good afternoon, sir. Hi, I'm Vinit Bhojanava and my ID is 1080. I'm in grade 9 studying in Bangalore. Welcome to my presentation on the final task for Intrepid Explorer. This is the bird's eye view of the arena for the final task. As you can see, it consists of two parts, a wall following and a line following part. Now, let's start with the working of the wall following. The robot or e-bug has 8 proximity sensors to sense the surrounding walls and obstacles, but I'm using only 4 of them to sense the walls. They are shown in the picture with these red lines. Now let's go back to the simulator to see how I use them. The front two sensors are used to detect an upcoming turn, and the sensors on the side are used to maintain a safe distance from the wall. Let's say there's an upcoming right turn up ahead. Let's ignore the side sensors. As you can see, the left sensor's value is smaller than the right sensor's value. So when we subtract them, it will be a negative value, which shows that there is a right turn up ahead. The same is true for when we need to turn left. As you can see, now the right sensor's value is smaller than the left sensor's value. So when we subtract them, it will be a positive value, which indicates there's a left turn. This is how I determine which side to turn. Coming to the line following part, the sensors are just proximity sensors or IR sensors that sense black or white as the colors reflect different amounts of light. There are three of them, which you can see as faint red lines under the bot in the picture. They are arranged so that they are perpendicular to the line. They also work similarly to wall following. If the left sensor detects a black line, the bot moves to the left, and if the right sensor detects a line, the bot moves to the right. The controller is a closed loop proportional controller, that is, it constantly takes feedback and actuates the motor proportionally to the error. Thus, finding the right proportionality constant, also known as the Kp value, was the main challenge. The primary way of finding the Kp value is via the trial and error method, but after many attempts, I wanted a better way or a less human intensive way of finding it. So, I tried fully automating the trial and error method. It took me a few days and I finally had a working version. The way I achieved it was by first using a small Python script to make a list of all the plausible Kp values and store it in a text file. Then, the simulator would use each Kp value and then record the time taken and store it in another text file. Then, I would use the Kp value which took the least time to execute. That's how I found the Kp value for this task, although I think I could make it even better. Thank you, everyone.
Nice work.
But
Raghu, I think
Thank
you
you,
should
sir.
start.
I was actually wanting this answer.
Yes, I guessed.
I was actually wanting this answer, and I'm so happy to see somebody has actually done it, right? And
Yeah, what have you done?
actually, I also wanted to hear how did this automatic solution conclude which is the right KP value. So he chose the fastest executing version to be the best. I don't see the simulation results though, so I can't make out the quality of the path that it navigated. Is there
Oh,
a simulation that shows that?
I recorded it, but I think it's cut off too short in the video, something like that. I explained the code too while the simulation was running, but I think
Can you share it
it's
now?
cut off.
Can you share it?
I have, I guess, one sec.
Yeah, I would like to see that.
Uh, I'm not allowed to share it. Could you please allow me?
Yeah, one
Ignal?
sec. Yes, sir.
We need check now.
Yeah, ma'am. Here's the complete video. I'll just skip over to where I. One second.
Just share the entire theme run, right? Share that video.
Could you give me a minute, sir? It's not loading.
Yeah, sure.
I'll just run the simulation in viewports if possible.
Meanwhile, I request the jury members to fill the scorecard I just shared.
I guess meanwhile I can ask one question.
Sure, sir. You're free to.
Yeah.
So, hi Vinit. Nice effort. You mentioned that you applied a closed loop controller.
Yeah.
Do you know what an open loop controller is?
So open loop is just kind of hard coded where it doesn't take feedback or it doesn't know what's going on in the outside world. It just runs a set of statements and
Would you have done your thing using an open loop controller?
like there will be no uh, you know way of correcting if something goes wrong. So in a closed loop control, you get to know what's going on outside, and if there is an unseen error, you can correct it back.
Right, but could you have done it using an open loop controller? Because you are in a simulated setup and
Yeah.
there are fewer variations like wind and all those kind of factors. Could you have done it in an open loop setup?
No, it could be hard coded. You could hard code the path, and it would move in exactly the desired state.
Okay.
Should I?
Yeah,
Just
Vinit, you
share
can
the screen.
just stop screening. I'll show you the video. It's with me. I'll share it.
I have the simulation ready.
Yeah, I have the final task video with me, so I'll share it here.
Okay, sir.
Yeah, otherwise you can share it. Fine.
I hope you can see the screen.
Yeah, I have the text editor in the console. So you
Okay.
can share it.
I'll start it until then. So the code is basically the same. In the first part we initialize the sensors and the motors, and then we get the values from the ground sensors. Then I've separated the wall following and the line following to different functions. So then there is a infinite loop where it decides, should we use the wall following, are we in the wall following part and the line following part, and executes. So the way I found it is, if it senses line, it goes to line following, it runs the line following function, and if it doesn't, it uses the wall following, just to give a gist of it. Yeah, it took about 1 minute 38 seconds.
Yeah, kudos to you. I mean,
Yeah, thank you, sir.
found the accuracy of the wall following was superb. It was really great.
Yeah.
And one of the best outcomes that I've seen.
Thank you, sir.
And I mean, I have only the standard questions. You said you are in grade 9.
Yeah.
And when did you learn your first Python, and who else helped you in this exercise other than e-Yantra folks?
So I started Python when I was in 7th. My father encouraged me. He knows a bit about coding, and at that time I used to see YouTube videos and some free courses were available. that's when I learned the basics of it. And in last year, um, there was another e-Yantra competition for, it was called game development or something. So in that they taught us how to develop games using Python. That's where I learned a lot more and learned different ways you could use Python and such. So that's where I had a lot of experience with Python, and
And
it helped
who
me a
gave you
lot
this
this year.
idea? Who gave you this idea that we should try multiple KP values and use the time to complete as a metric of goodness?
There were previous tasks too where one only had wall following and line following. There too, we had to find the KP value. But after all those sessions, it was like tiring and kind of boring to find the right KP value. So what I thought was I'd give all the plausible KP values, just incrementing by 0.05, and I made a Python script, so it would run a simulation with all the
Okay.
KP values. So then I would record the time taken with another Python script,
How
and
do you
then
know that the simulation didn't crash somewhere, the puck didn't crash somewhere in
yeah,
between?
like I detect the walls, right? I detect the walls if it touches the walls, or uh, if it touches the wall, it's not counted. And
Okay.
I even gave it a time, say like 10-15 seconds. In 10-15 seconds, if it didn't make this far, it didn't reach that coordinate, it would also be it's not working or
Oh,
such. So
okay. Okay. That's all I have.
yeah, thank you, sir.
So boredom was the reason for choosing
Yeah,
the
kind of, yeah,
contest. Yeah.
that's how we automate all the things. Not exactly boredom, but yeah.
Yeah,
Yeah,
this.
yeah, I meant it in jest. So.
Yeah, yeah.
By the way, Milind, this is the closest you'll see to a joyful expression on Raghu's face.
Yeah, yeah. I mean, I have to say this has really blown away. Didn't expect this. I was hinting at this in the previous question, the Viva question to the previous team. I wanted to see if anybody actually did this, and wow, next one I see the same answer. Small extra improvements are possible still, where the KP is dynamically computed as we go along, but that's a little further away. But anyway, this was really good.
Thank you, sir.
Okay, if you can stop sharing the screen, I think we should
Yeah.
bring this up to get into the next session. But if everybody is on, then are there any other comments that the jury would like to make, observations about this, which the kids can take away with them?
Well, it's good that some of the schools are encouraging people, all these kids, to take up Udemy and Coursera courses. Good that they are getting an opportunity to learn these tools and start practicing them early. And parental support makes a difference. We can see that.
You haven't asked Vineet as to what parental support he had got.
He said, I mean, father encouraged.
Acha, okay.
Yeah, he said that.
Oh, he knows a bit of programming, he also said.
No, he encouraged father.
Yeah, yeah.
Father encouraged him to learn programming. I don't know whether the father himself knows programming or not.
Yeah, he knows, like he is quite in touch with he was quite in touch with Visual Basic and C.
What does he do?
He's an engineer, design engineer, but he was quite interested with programming, so he learned programming while learning that. And
So he's a design engineer with in
yeah.
what area?
Sorry?
He's a design engineer in what area?
He makes design like pumps, filters, such.
Okay. So did he take interest in the way you were going about and solving your problem?
Yeah, like he would give different ways you could reach the problem, or with his experience you could say, like try something like this and it might work. And yeah, he inspired me a lot to finish this book.
Good, good. I think Viraj has a question. Viraj, do you want to unmute yourself and your video and ask it?
Uh, yes, so sorry, and actually there is nothing here, so I'm keeping my video on.
Viraj,
But
you're not audible. Can you come again?
hello,
Yeah.
yes, means in the earlier discussion, actually, my point was not reached well. I actually told the same thing. Means this KP is a constant, and this can only be computed by doing experiments. So I chose all the KPs from point zero 0.01 to point 0.35. So I have done each and everything. Means I just wanted to say that my point was not reached well. So I just wanted to say that.
Okay,
And,
will do.
and this KP thing, I actually means my answer was we can keep more than one KP value, but that will only make the code more complex. Means that was my point. So yes.
Okay, will do.
Okay. Okay.
Partha, anything you'd like to say before we move on?
Yeah, I was really happy with everybody's effort. I think just keep up the enthusiasm and yeah.
Good, thank you. And Paritosh?
Yeah, so I think it's great to see that school students right from 6th, 7th standard to 11th standard are attacking these questions and are able to solve them. They come with some background in Python programming. Now, one thing I was curious about was that you have been given this boilerplate code, right? You have been given the basic simulator with the design of the arena and the bot and everything, and you had to basically tune the algorithm, right? But how many of you actually got interested in how this whole thing works and started reading the VBot's manual and see what are the parameters of the sensor, what are the parameters of the motor? So this is for the participants. Did this encourage you to delve deeper into the design of the robot and the design of the sensors and such things?
So basically, we are Team 468.
Yeah.
And while we tried to solve our problem, there were a couple of issues, especially in task 6, wherein the V-bots actually started going into a projectile motion when it hits the road. And apparently that's because of some mesh issue with respect to the road module in VBot. So we had to read the manual to understand why this was happening. And also, sir, there was another issue wherein the VBots, the ground sensors, which are 3 perpendicular sticks to the base ground, those did not work properly, and it only worked when the middle stick detected the line. So, now, in the case of task 6, while we made our own line following arena, we made sure that the VBot robot had a proper flag system wherein it easily converts from the wall following to the line following. However, we had to make sure that the middle ground sensor GS1 was correctly placed at the center of the line, or else it wouldn't detect and it would just go away from the line.
I see.
And another issue that we had to face was the 6.28 radian per second issue, wherein because of the error going greater than I think 3.75.
To the max velocity. Yes.
Yeah. And also in the crest of that
Empowered
turning.
enough to try to design your own robot or to modify epoch?
Basically, in task 6, we didn't know how to make our ground sensors. So we tried to make our own ground sensors.
Try. Okay.
and it didn't work sadly, but we got the help from Agnel sir.
Okay, nice.
Okay, very good.
Thanks.
So, in the interest of time, we should call a halt here to this phase of the competition. We split it into two parts, and we have a separate jury for part one and a distinct one for part two. So, I'd like to thank all our jury members and the students for having taken part, and for you guys for having come so far and really pleased us with the work that we've seen. Thanks for that. And each one of your jury members are exemplars of what engineers should be. So it's a privilege for us to have them here with us. A big hand for them, all of them, for having taken the time and given this event the importance that they've given it. We really appreciate that at e-Yantra. And Prof. Partha Pandit here, as I said, he's in the AI area. I'd like to ask him a question. Partha, do you see a possibility of us designing an AI-based theme? And what is the class onwards that you feel that we can teach AI to students?
I don't know how many of them actually use ChatGPT or something like that to write their code. I certainly use it every day when I write code these days. So
you didn't ask them that.
Yeah, I should have. I realize that now. It's a good question. I'm not sure. Maybe it's not a bad idea to start talking about AI early on. But yeah, what sort of matters at the end of the day is you need to study math really well as an engineer always. So yeah, I guess the curiosity always helps. So we should get started on that earlier. But at the end of the day, you do need to study math to understand these AI concepts or even the robotics concepts that they've worked with. What exactly does KP mean when you tune this parameter, and why does it lead to oscillations in some sense and slowing down in other cases, right? Understanding this ends up making a big difference in practical systems with real robots. So, yeah.
Okay.
Can
Thanks.
Can I make a quick remark?
Yeah, Professor Pandit, please do.
Yeah. So, I mean, it is quite different from what all of the juries and the this thing have said. I just wanted to tell the students that I hope they are doing some physical activity along with all these participating into this, because I think they should miss on spending time on playing on the ground and making friends and spending time, because I think at the end of the day, that is also equally or sometimes even more important than just doing robotics and other things. So I hope they are also knowing about it and they are doing it along with I mean, I enjoyed, of course, all these conversations, but I am really concerned about the time that they have spent, because if they've spent so many iterations to arrive at the solution, yeah, I mean, that's my take.
So, Prof. Shubha, maybe what we should do in the next lot, you should ask them that question as to how many have compromised their
Yes.
physical
I mean,
activity while doing all this.
I sincerely feel, because school as it is has a lot of other activities that they need to attend to. In addition, if they are doing this, they have taken off their free time, which otherwise they would have spent in games or play. I mean, not the video games, the physical activity, I mean.
So was that your experience at home?
Oh, my children used to have a lot of ground activity. Yeah, a lot of time every evening they have spent on the ground and playing, formal games. Yeah.
That is Professor Shubha Pandit, who is principal of KJ Somaya College, which is a very distinguished engineering school. And she's been with e-Yantra for a long time, and she's seen what we've done. She has an e-Yantra lab in her college and so on. And now she's working a lot with us. So her advice is very important. I would like the youngsters here to heed it. So without much ado, let's go on to the next lot. We have one new joinee here. Partha, your
yeah,
can I get a small break?
Yeah,
Can we
yeah.
get 3 minutes of break, please?
Absolutely, absolutely. In the meantime, I'll just introduce our new jury member, Madhura Purna Pragna, and she's worked with us in the past in the lab at IIT Bombay, and she's Dr. Madhura Purna Pragna. She is a principal member of technical staff of AMD, the chip maker, and she's a professor in PES University in Bangalore. So she's an MSc in electrical engineering from University of Alberta and a PhD in electrical engineering from Paderborn University, right, in Germany. And her research area is building custom accelerators, chips for deep learning and graph applications, right? In designing the circuitry, the chips to speed up these kind of applications, domain-specific chips, and simplifying the RISC-V, which is a kind of architecture, RISC-V based custom design exploration, right? So she's a hardcore engineer in that sense. And under her guidance, her students have excelled in projects ranging from performance modeling of complex algorithm on large large variety of devices, developing custom architectures for deep learning, and working a lot with FPGAs. So the intersection between reconfigurable computing, which is FPGAs, reconfigurable hardware, and AI seems to be her core interest at the moment. So she's just joined us now. I've already introduced you all to Raghu and to Professor Pandya and Partha. We have Prof. Shubha Pandit also, who is to be a principal of Somaya College, and she's a PhD in electrical engineering from IIT Bombay. So that's who we have here with us. We'll have a short minute-long break before we go on. So Madhura, you've seen a little bit of this. Any comments?
Looks good. I'm wondering why my kids are not doing all of this.
Maybe they're busy playing outside and they're
Yeah.
living the
Yes.
healthy life.
Yes.
So Madhura, we have Shubha here who will be thrilled to learn all this from you, that you kept your kids on the right path, basically. But what's nice about everyone that we have here, they're all friends of e-Yantra, and they're passionate engineers, each one of them. And I think they're all a role model and exemplars of what engineers should be. And this is what our country needs a lot of, if it's to kind of, become Viksit Bharat and make in India and all that kind of stuff, right? More engineers need to go into hardcore manufacturing and chip design and building stuff, rather than joining fintech and all these kind of things where they're just playing with other people's money, right? So, and that's going to become more and more important. I must say that when I came back to India many, many years ago, a PhD did not have that much value because we were not creating new stuff in this country. But as India is moving up the value chain of technology and all these types of things, it becomes much more important that we create technology from scratch in this country, because that's where the value exists, rather than doing godagiri for other people in software and hardware design and all that type of stuff. So each one of us here represents that spirit in our engineering fabric in the country. So Madhura, perhaps you can tell something more about what you're doing, because Raghu here would be extremely interested in knowing.
Thank you for introducing and putting in a lot of details about me. Yeah, I'm always curious to see how I can encourage youngsters to think beyond what is given to them and told to them. Can't they come up with ideas of their own? That's been a pursuit. I see that youngsters are very enthusiastic and just need some channelization to, in the right direction to go forward, go away from the beaten track, I would say, which is much needed in innovating whatever we are looking into. e-Yantra is doing a good job in posing these problems so that students, kids can come up with innovative solutions. Yeah, give them a problem that they can solve differently. I think that this is becoming a good platform, Dr. Arya.
Great. So I think maybe we can move on, and Raghu can join us when he comes. And in the interest of time, because we don't want to stretch this out for too long, we'll get going. So have you been introduced to the problem as such and the presentation that we've given and so on? Has the team given you that? Madhura?
Presentation?
On the theme, layout and tasks and all that?
No,
No.
no, sir. Like ma'am has just attended one video. Ma'am, shall we do a breakout with you, like a breakout session, or
Yes.
is it okay?
Quickly, if you
Why
could.
don't you do it here itself?
Okay.
Run through that video which describes all the tasks and just run that little bit fast. It should be okay. It'll be a good
Ashish?
recap for everybody.
Okay.
Sure, just a minute. I'm just sharing my screen.
Okay, I'm back.
Good to have you back. We're just playing Madhura, the outline of the tasks.
Okay.
So Madhura, that gives you an idea of what's there. So perhaps I'll just hand over the floor to Agnel. And please let us know, Agnel, how much time we have to spend on each team
Sure, sir.
in the interaction. How much time is that?
It's averaging around 8 to 9 minutes, sir.
But it should be 6 minutes, right?
5 minutes.
5 minutes. Okay. There we are. So over to you, Agnel.
Okay, sir. So we'll continue to the session 2. So we'll start with team 478, Varun Reddy, Pranav Reddy, and Vigant Polsani of the Gadium School, Sangha Reddy.
Greetings to all. Our team name is Cerulich, Amarok, and Miradon Riders.
Our team ID is 478.
We are from the Gaudium School, Kollur, Hyderabad. I am Pranav Reddy Patlola. I am Varun Reddy Palagalapalli.
I am Bihan Posani. We are all in 7th grade.
First, we will present you the output of task 5 and then demonstrate the algorithm that we followed to write the program for task 5. Coming to the program, we have defined two controllers, line follower controller and wall follower controller. If any of the epoch's ground sensors 0, 1 and 2 detects the black line, then it uses the line follower controller, otherwise it switches to the wall follower controller. In wall follower mode, we have primarily used the PS1 and PS6 proximity sensors to maintain the epoch at the center. In our program, we have assumed a particular distance as the center position for the PS6 and PS1 sensors, approximately 140.92. And based on a deviation from the distance, the epoch will move either left or right. If there is no deviation, the epoch will move straight.
In line follower mode, based on the difference in the color detected by the ground sensor 0 and 2, the epoch changes direction. Suppose GS0 detects white and GS2 detects black. Epoch will move right to adjust itself on the black line. If both are detecting black, it will go straight. We also added weightage or turning fold to the deviation or error that was detected in the line follower or wall follower mode in the form of KP. We have 0.05 KP value in the wall follower mode and 0.26 KP value in the line follower mode.
We tuned this program further by setting the speed to the max speed, and we also included the PS1 sensor to adjust the position in the wall follower mode. As we have reached the conclusion of our task 5 video, there are just 2 words I would like to say. Thank you.
Or to Madhura ma'am.
All right, so nice work, boys. Can you tell me why you had to switch between the two types of controllers?
So that we can not hit the edges or something like that. So we can maintain the two distances between the wall, so that it can be put at the center.
But there is a line always, right? Why did you have to switch between the two?
Yeah, because actually there's no wall over there in the line follower. So we had to switch to the line follower.
So there is no wall, so you have to switch to the line follower. Is that the point?
Yeah.
Yes, ma'am. There was no wall, and since we weren't able to use wall follower, we had to switch to a line follower.
Okay, and did you see any change in the rate at which the robot was moving when you were switching?
Actually, we saw a little bit of confused turning for I think for 1 second, I guess. So after that, it just normally follows the line.
So you did see a difference.
Yeah, we saw a small difference.
Okay, and then what was the challenging part for you guys? Where did you and where did you fix it, and did you discuss among all of you, and or was
Yes,
it
ma'am.
one
It was the
person?
speed of the epoch.
And also tuning the KP value.
Okay.
So basically, for the KP value, the e-Yantra team told us it's from 0 to 2. The KP value will be somewhere around 0 to 2, that it will be different upon each robot. So what we did, so first we started from 1.5 and then we saw from 0.5, and as the changes, we take these two values to a single value.
And how did you arrive at that value? You just tried different values, is it?
No, so basically we took one extreme of the value which the e-Yantra team told us, and we took the other one. So based on that, we centered those two values and we just took the average of it.
Okay. And that was good enough. You didn't have to go back and forth changing the values.
Yeah.
Okay. Okay, so I want to hear more about how did the team work together? Who did what?
So like uh, we all sometimes we do in online meetings, or mostly we come together and do it all together.
So
So
you work together?
yeah, like so we meet up and do it. So sometimes whenever we are in like any sort of problems or something like that, we discuss it among ourselves, and then we come to one conclusion.
And if we need more help, we use some research and use the MD book and the resources that were given from the e-Yantra team.
Okay.
We also ask like our coding like teachers to like help us with our problems.
With the coding problem. So programming was harder than solving the problem with paper and pencil. Is that how you see?
No, not exactly. I think coding is like just much easier than solving the normal problems.
Okay. Okay, over to the others.
Paritosh,
What? Hello, yeah, nice solution. First of all, which class are you from?
We are from 7th grade.
7th grade. Have you done any programming before?
I have I've done programming before since 5th grade
In Python or in?
in Python.
Okay, nice. So it was good
This
to see Python being put to use, yeah, on a
Yeah.
real robot. Well,
Yeah.
simulated.
I
Okay.
learned the basic functions before the competition, like in 6th grade, and then I learned more in depth once this competition started in the meetings.
Okay. What was the most fun part of the project?
The most fun part of the project was actually solving the problems because it was challenging, and it also kept us from boredom.
Okay, nice.
for me, it's like testing the code.
I see. Okay. Uh, so, one of the things that you have to do in this project is to try to make your robot finish the task as fast as possible, right?
Yeah.
Yes.
What do you think impacted the speed of the solution? I mean, where is it that the difficulty came and what did you have to do? I mean, you could have made it move very slowly and then it's very easy to adjust.
Yeah.
We had to set the epoch at maximum speed.
And also the hardest part of doing the time optimization was like quickly doing the KP value, because if the KP value is too much, it has high reactivity,
Right.
while the KP value is very low, too low, it'll react very slowly and it has chances of hitting the wall.
So, given that fact, uh, how would you achieve the best speed? I mean, which KP value will you choose? And will the KP value remain same throughout the run?
Yeah, for us it remained the same.
Mhm.
We use trial and error to find this like the exact
Value.
KP value.
So who else helped you apart from e-Yantra people?
Apart from the e-Yantra people, I got support from my mother.
And what does she do?
She's a software engineer.
Okay. And the KP value trials, you said you took some center point, but obviously it's not really the center. You had two extremes. You must have chosen to start with one value. How do you know in which direction you must make the next change?
So first we take for example, if it was from 0 to 2, what I would do, I would first try 0.5 and 1.5. So if in 0.5 it is like like it has very less reactivity, while in 1.5 it is more. That means we'll know that it's in between both of those values. Or else if it is like still if 0.5 has less reactivity and 1.5 is has less reactivity, that means we know that it is above 1.5. And then if it has high reactivity for 0.5 and high reactivity for 1.5, then we know that it's below 0.5.
Okay. And all the sensors were used, or you chose to use only some sensors?
For the line follower, we used all the sensors GS0, 1, and 2. But for the proximity sensors, like for the wall following, we used only 1 and 6. PS 1 and 6.
Okay. And why did you do this? Why not use all the other sensors also for the wall following?
So like so we tried that, but then we felt like it was too much of reactivity because all the sensors are like at once they are giving their like they're giving the value and it has to calculate it, and then it's like high, it's having a high reactivity.
Okay. And you guys said you met uh, face to face. Are you all from the same? You're all from the same school, right?
Yeah.
So why not meet every time face to face?
uh
Why online
some,
sometimes?
sometimes like uh it might be that we don't have time, so if we usually meet up, it's like a whole day.
And we're also
Oh,
far from each other.
you're also far from each other. Okay. Okay, I have no questions.
Thank you, sir. Thank you, team. So we'll move on to the next team. So the next team is 5066, Tushar Vivek from National Public School, Bangalore.
Yes, sir. Can you hear me?
Yes.
Robots are great at following tasks, but what if they need to switch between two tasks? That is what we're going to be seeing today in the output video of task 5. My name is Tushar Vivek. I study in 8th grade National Public School, Rajajinagar. Welcome to the output video of task 5. Now this is the simulation of task 5. It employs two classic concepts in robotics. One is the wall follower and the other is the line follower. Now these concepts that you see here might be just a simulation, but they are the same concepts used in larger robots, like the ones that navigate warehouses or self-driving cars, for example. Now let's start off the simulation. Now it starts off with a wall following controller. How this works is the epoch uses the proximity sensors on its sides to determine how far away the wall is. If it is too close to the wall, it steers away from the wall. But if it's too far away from the wall, it steers back towards the wall. It uses something called a proportional controller, which is, and how it works is, it checks its current position to its ideal position. It checks where it is currently to where it should be. And this difference is called the error. And based on the error, it decides how much to turn. If the error is very high, its turn is more aggressive. But if the error is small, the turn is more gentle. Now let's see what happens when it runs out of wall to follow and when it encounters a line. It smoothly shifts to the line follower. Now these are two separate parts of the code. So how does it know when to shift to the line follower? Now here's where the infrared sensors come in. The infrared sensors, they emit light at the ground and measure how much is reflected back. So if it is a white surface, like this white floor you see here, it reflects a lot of light and gives a high reading. But if it touches a black line, then since black is more absorbing, it gives a low reading. And based on this, you can use it to detect a line. And when the epoch detects a line, it shifts to the line following controller. The error in this case will be the difference between the left and right sensor values. So if one sensor gives a high value and one sensor gives a low value, it knows that it needs to make a turn. And there you have it, a line follower and a wall follower in the same project. Thank you for watching.
So
Raghu?
I'll go. Okay, you go, ma'am.
Raghu, you can start.
Go ahead, please.
So, in your wall sensor part of the code, how many sensors did you actually use?
I used two sensors, each on the left and right.
Okay. I think I can see the difference between people who do two sensors and people who do more sensors. I can see that. Do you see in your wall follower that it was veering to some of the closer to the wall on either side?
Uh, at one point of the turn, I noticed it was like getting a bit close to the wall, and if the KP was like slightly higher, it would have hit the wall. But I tuned the KP so that it can make the turns.
So what can you do by using the other sensors? You chose two, but what's the problem in using the other sensors, and what could have been done better with the other sensors?
There are 7 sensors in total, and there were only 2 on each for the robot. The others were like in the front and back. So if I wanted to, like, if there's a wall directly in front of it or some situation where it's a dead end, then maybe I could have used the front sensors. But in this case, it was not needed, and it did not help the project.
Actually, when you see curved walls, don't you think that you will see walls in front before you actually reach the curve?
Yes, I think the front sensors would detect the wall, but like by the time it is close enough to actually detect the wall, the proximity sensors would also, I mean, the side sensors would also have picked up some readings. Of course, it would have been better if I had used the front sensors, but
did you experiment?
No,
Okay.
I did not try that out.
Okay. And you did you are from 8th grade. Did you do Python programming before this?
Yes, I had done Python programming before, but I hadn't attended any course or anything. It all started like when I attended AI bootcamp by Intel, and they needed us to use Python to build the project. So
How
that's when
long
I
ago was this?
started to learn Python.
How long ago was this?
It was during the lockdown, so 2020.
3-4 years back. Okay. Okay. And anybody else apart from e-Yantra folks helping you?
In task 1, there was a lot of maths involved, which was a bit more advanced than what I'm currently studying. So my mother helped me with the maths equations. But
okay, and what does she do as a profession?
She's a civil engineer.
She's a civil engineer. Okay. That's all I have.
Right, nice work, Tushar. So you worked alone on this, is it?
Yes, ma'am.
Okay. Can you tell me something about error that you mentioned? You said there is error and then you adjust according to error. What is that error?
So error, let's take an example of the line follower. So like the left and right sensors will give different readings. So if it's touching a black line, the sensor touching a black line will give a low reading, and the sensor on the white part of the floor, it will give a high reading. And the difference between these two is called the error. And based on that, you can find out which direction to turn and by how much to turn.
Okay, that's in the line follower. What about the wall follower?
In the wall follower, the error will be like how close do you want to be the wall how close do you want to be to the wall? For example, if I want to be at like 180 centimeters from the wall, and the robot is at 90, so it knows that it needs to move away from the wall to
reach that set distance, and 180 minus 90, in that case, that will be the error.
But you don't know, right? You don't know how far you have to be. How did you set that?
Uh, Initially, like I made the robot print the sensor value. I made the simulation print the sensor values. So when it was at the center, I just checked what the values of the sensors were
So you
and
need
used
a
that.
reference, right? You need a reference.
Yeah, you need a reference.
Okay. Would you have done something differently in place of error? Would you have done something differently?
In place of error, well, I initially started off using if statements, but like when we got to the proportional control uh, part of e-Yantra, my project got rejected once because I was using too many if statements. So that's when I shifted to the proportional controller and found it's a much better way to execute the project.
So you wouldn't be able to go on a unknown path, right? With the error calculation for the wall follower. You will have to run it once and then
No, you can, even if you give it a completely new path, it will run perfectly fine.
how would you calculate the error then for the wall
The
follower?
error is calculated automatically every simulation step. So the error will be its current distance
I
subtracted
see.
from
Okay, every
the
time. Okay.
set distance.
Mhm. Okay.
Thank
So
you.
was it easy for you to do it all by yourself? You didn't have others with you, or how do you see that?
In task one, like I said, there were a lot of maths calculation involved, which I had not studied yet, so my mother helped me. But after that, it was I was able to do it on my own.
Okay. Over to
Yeah.
others.
Thank you, ma'am. So thank you, Tushar. We'll move on to the next team. So the next team is 82, Dwargesh from Indu Colony, Shallamal Vidyalaya Senior Secondary School, Chennai.
My final task output video. My name is Dwarkesh. My team ID is 82. I'm currently studying in 10th in Hindu College, Chalman Vidyalaya. So let me talk about the arena. So the first stage of the arena is about wall following, and the second stage of the arena is about time following. So let me talk about the problems which I encountered. So the first problem is that the IR sensors of the robot may sometimes come out of range with the wall when doing a sharp turn or a U-turn. And the second problem is that the robot has to be switched between line following and wall following based on the wall and using its own sensors. So let me talk about the ideas to combat this problem. The first is that normally the robot uses the PS1 IR sensor to follow the wall. So when the PS1 sensor is out of range, it automatically switches to the opposite side, which is in PS6 sensor to follow the wall. And also I'm using the PS5 and PS2 sensors and also the PS6 and PS1 sensors to effectively switch between wall following and line following based on the wall. So this is my simulation of ePunk in VBot. So you can see it automatically switches between the PS6 and PS1 sensors based on its range from the wall. So when one goes out of range, it automatically switches to the other to do the turns. So one advantage of using this kind of solution is that the EPA could normally travel fast during a straight turn, and also while during a U-turn, it could travel a little slower, and also it could increase its accuracy. And you could see automatically switch between wall following and line following, and you could see it's running the line following code. And also, I wanted to say that my time required by the EPUNK to travel this entire arena was around 1 minute 30 seconds. So my EPUNK could completely finish the arena in 1 minute 30 seconds. You could also see the robot is able to effectively make 90-degree turns. The robot runs a simple P control. So let me talk about the program. I'm first creating the instance of the robot, and then I'm defining the max speed, and then initializing all the devices, the motor as well as the sensors. And then I'm creating a special value called status, which will be used to switch between wall following and line following. You could see there's a function for wall following, and then there's a separate function for line following. So inside the wall following function, you could see that there's a if block to switch between the two sensors based on its range from the wall. And also you could see the line following. I'm reading the ground sensors and then running a K control. And you could see there's the main while loop. You could see there's a if block to effectively change between line following and wall following based on the sensor's range. And you could see the status value being changed in order to change between line following and wall following. Thank you.
Yeah, Madhura ma'am.
Nice work. Can you tell me why you would notice that there were segments where the robo was slow?
Actually, if you see when the robot is moving, when it's as a time, see the sensors will come out of range with the wall. So actually, because of that, I have to switch between the sensors. And also, if you see, if your robot is going to travel in the straight path, your robot could actually travel very fast. In the real life, you could see in the straight path, the robot could really like move very fast. But actually, during turns, we need to slow the robot. And I also wanted to as a separate peak control for the turning and for the straight line. So when in wall following, if the robot is traveling a straight line, then it has a separate KP value and a special K control. And when while turning, there's another K control with more accuracy, so that it can take a correct turn with the center. It maintains the actual center. It doesn't move like left or right. If you could see in the other projects, you could see it was slightly moving towards the left or towards the right of the ball. I didn't want to do that. So that's why I created two controls to mitigate that issue. One will be more accurate and one will be less accurate, so that I can switch between them.
Okay, so there were turns and there were 90-degree turns, right? Even there was difference between the two, correct? Could you say why that was?
Actually, if you see in the wall following, we have the ability to change between the sensors, but in the line following, actually, I generally had only three sensors to work around. We didn't have a lot of other options to work around for the 90-degree turns. That's why you could see in the line following, you could see the robot slightly gibberish in the 90-degree turns. But for the wall following, I used four sensors. For redundancy, actually, you see, even if some sensors fail, I had actually used four sensors so that if it could detect, it was detected by other two sensors, it could work with the other two sensors. So in the line following, we had only three ground sensors to find the value. So actually, because of that, we didn't have a lot of space to work around for the 90-degree turns. And actually, we didn't have a GPS coordinate to find if the robot is in like which part of the arena. We didn't have any kind of coordinate systems to do that. So because of that, the 90-degree turns, we had to make the KP value a little bit based on the KP values, you had to adjust it so that it could also do the 90-degree turns more accurately.
Okay, so how did you arrive at this method, and were there other alternatives that you were considering?
Actually, about that, ma'am. Actually, first when I started, I actually created a PID solution. I had integrated the except from K control, I also integrated the derivative and the other terms. But when I was running the program, I would see it was taking a lot of speed from the controller. You could say I actually wanted the program to be very lightweight, and I didn't want to take the performance of this controller. I needed the controller in the EPUM to be able to do other tasks. So I created just a K control with that, and by using the K control, I was able to do the wall following and line following. I actually added ID other solutions, but it was taking a lot of computational power from the EPUB. So I switched to P control, which was the lightest of all.
So what do you mean by computation power? How can you tell that it takes more computation power?
Yes, actually, if you see for calculating the PID value, it has to calculate three values, and it was taking a longer time. Actually, if you see and if you're going to run it in a real life controller, it will take more hertz from the more computational time to run the specific task. But if it was just a single value, it could complete the task within a less amount of time, and I could use the remaining seconds to do other tasks or calculate other variables.
Okay, all right. So what grade are you in? I missed that part.
I was in 10th.
You're
Currently studying.
in, you're in 10th and you're comfortable with programming for a while?
Actually, ma'am, I have started Python programming in the 7th grade. Actually, the first experience with Python programming was in e-Yantra competition. Actually, I participated in 2 more teams before this. So in both the first time I was introduced for programming was in the e-Yantra. So from that point on, I started to learn Python programming, and I in 7th and 8th grade I participated in a virtual museum as well as a game inventor. After in the 9th standard, I actually we had to change some places and was busy with the things, so I was not able to participate in the 9th grade. But in the 10th grade, I wanted to participate in the game. I wanted to participate again.
Okay, thank you.
So
Over to
why
you.
did you choose? Why did you choose to use only 4 and not 6 sensors? You had 2 more in the front, right?
Yes, sir. Actually, if you see, if I had to use the other 2 sensors in the front, it was mostly out of range. If you could see, if you only the 4 sensors were mostly come in contact with the wall, and the other 2 sensors are mostly out of the range. It was not it's
Except
located
when
in such
making
a way that
turns, right?
yes, sir. Actually, when making turns, I actually wanted to use the other sensors, but I felt that just by using the 4 sensors, it was really accurate. I didn't see any kind of deviation from the path. So that's why I actually went with just 4 sensors. So if I had to implement other sensors, I could have, but it would take more like what you say, it would make the program more complex. It was simpler this way by using just 4 sensors.
Okay. Who else did you take help from apart from e-Yantra?
Actually, sir, both of my parents are from non-background programming sync, so actually I had to do all the things. If I had some doubts, I would search in the internet and get it out.
Okay. Fair enough. Okay. I have no further questions. All other questions have been asked.
And also, actually, but you asked about automating the KP value, sir.
Yeah, you have
Actually,
heard the.
about that, actually, I wanted to create that kind of solution. But if you see, my KP value had 5 decimal points. After the point value, there are 5 values after point value. So actually, if you see, I felt it was much more easier to manually change it, because manually changing it, I actually wanted just tweak it a little more time. Because if you could see, we had already 2 weeks before this to implement a special wall following and a line following code. So we already had a approximate KP value for both of these. So I didn't need more time to again calculate a KP value from the very beginning. So I already had the KP values. So I didn't go around and started implementing the automating solution. If I had implemented an automating solution, it would have taken a slightly more time, because the computer would have started from a larger value. It had to work around a larger value. But because I'm doing it manually, I could see if there's a sudden it was too vibrating, I could suddenly change the values, because I felt it was much more faster this way than doing it automated and creating
Well, that's one way to look at it. But after all, a machine can run throughout the day, right? You don't have to spend your time. And
yes, actually,
one more point, the software complexity in terms of coding is a one-time effort. If it's runtime complexity, we'll accept it. If it is not runtime complexity, if it is just there on paper that it took you longer to code, it doesn't matter. At the end, all that matters is at runtime, how expensive is it to run? If it's not expensive to run, that should be answer that's taken.
Yes.
Okay.
Hi, Dwarkesh. Which school are you from?
Actually, I'm Chalam, sir. In the previous editions, I was studying in a different school. 9th standard, I changed my school.
So
now
you
I'm
were
studying
in before, right?
So, yes, sir. Actually, I was in Houthi. In 7th and 8th, I was studying in Nilgiris. After that, I changed to Chennai. In my 9th grade.
So he's if you like, Raghu, an e-Yantra kid. He's kind of grown up with us.
Yeah, I saw that. He mentioned it.
Yeah. So I think the Dwarkesh, there are some very important points that Raghu has made. And I'm just wondering how to transmit this idea to more young people that an engineer needs to think about optimizing what they are doing by uh, how do you find the best solution, right? And I think it was quite well illustrated by one student who wrote a script trying out various options, recording the results and seeing which one took the least time. And that's a very elegant way of solving the problem because then you know that that is the best answer that you can get. And then others tried out playing around with integers versus floating point, right? Because floating point, each floating point computation, it translates into the machine into many lines of machine language code, many lines, almost about 100 times more. Yeah, Madhura, please correct me if I'm wrong. Okay, so as a result of that, each floating point computation takes much more time to execute on a computer than an integer operation.
I
Right?
would
So,
only correct you, Kavi, on this. Now, not modern processors.
oh, you have floating point units and all that.
You have all SPUs that do all kinds of magic.
Yeah,
So
but
it's all
yes.
earlier generation micro-coded, etc. But current generation, everything is done in silicon. So, and you have FPUs on most of the silicon these days.
Okay, but there's been a difference in the amount of time their computations have taken
Data
with
movement.
integers and with the floating point, no?
Yeah,
Depends on
that they do. That is true. That is true. Of course, integer math is always faster.
Yeah. So these are all insights that we have, which I think Paraghu has been pointing towards. Can you think of a good way to transmit it to young people as to what is the right attitude for engineers to have? Is this something that can be uh, taught or trained, or do you
So
expect
let's do that
it to
at the end of the. Let's do that at the end. We are taking valuable time. We'll summarize at the end.
Yeah, but just think about that. We'd like a
Yeah.
response to that question. We can move on now. Agnel, over to you.
Yeah. Thank you, sir. Thank you, Darkesh. We will move on to the next team, Team 495, Avade Dubey and Avarna Krishna Abhilash from the Millennium School, Dubai.
We are Team TMS with Team ID 495. We are from the Millennium School, Dubai, and I am Team Leader Arav Krishna Abhilash of Grade 10.
And my name is Advay Dubey, and I'm also in grade 10.
In this task, we implemented a P controller for the epoch to follow the wall as well as the line in the arena. Using this algorithm, our robot avoids collision with the walls using proximity sensors and traverses the walled arena. Once it reaches the tunnel area, the ground sensors detects the line and starts following the line to reach the destination using line following algorithm. Along the path, the robot collects all the waypoints on its way. We are able to collect all the waypoints and reach the destination of the epoch within the given time frame. Thank you.
We seem to have lost the audio.
There is no audio, I think.
No, sir. That is the end of their explanation.
Okay. But the screen is also static.
No, the robot is moving.
Okay.
Paritosh,
Yeah. Okay. So can you say something about your solution? In the wall following part, how many sensors did you use?
Yes, sir. For the wall following part, we had used four sensors, the proximity sensors. We used them to generate an error value, which we then compared to the desired value.
Yeah.
And after subtraction, we coded it to follow a specific path. So
Understood. Could you have solved this problem with just one sensor? One on the left?
No, sir. With just one sensor, we wouldn't be able to solve it because we need two sensors because there are two walls to detect. So
Yeah, but what is an error? Let's not go into too much into the code. What is an error? Given these two walls, you want to keep a certain distance from the left side wall, right?
yes, sir.
This is called the left wall hugging strategy. So one sensor would be good enough, right?
So here
Sir,
we
but we have some curves in our code.
Sensor. How do you combine the readings of two sensors to get a better error value? I mean, please explain that.
Yes, sir. So for this path that we've been given, there are many curves in the path, and as a result, just one sensor wouldn't be able to work as efficiently as compared to two or multiple, sir.
So can you elaborate? Because even at the curve, there is a wall on the left. I can just keep certain distance from it and keep moving ahead.
Sir, yes, that is true. We can use one sensor just to sense the left wall. But what our objective here was that we wanted to be able to adapt to different widths. So for that, we'll have to take the values of both walls, because if we just take the left wall,
Okay.
the wall has a, if distance changes between the left and the right wall, then we will not be able to maintain the center line.
I understood what you said. So your objective is to keep to the center of the between the walls even when you are turning, right?
Yes.
And did you achieve that?
Yeah, mostly we did. Maybe there were a few places where it did divert a little, but mostly tried to keep to the center.
Okay, thank you. Yeah, I got this one question. What is the impact of increasing KP on your solution?
Sir, if there is increasing KP, then there is more reaction, you can say. So, for example, if there is, let's say there's a lot of diversion from the center. If the robot diverts from the center, then you need to have a higher KP so that the robot can divert, it can get back to its intended path much faster. Otherwise, if you have a low KP and a higher diversion from the center, then it will take a long time to get back to its center place. So
Okay.
lower diversion, lower KP, higher diversion, higher KP.
Yeah. Now, if you increase the KP, what will happen to the speed of the robot?
Sir, if you increase the KP, then there are chances that the overall speed may decrease, because then the robot will become overly sensitive to diversions, and that way it might go in a bit of a zigzag line.
No,
So
but
that
sorry, I don't understand something. Your motor speed is proportional to error multiplied by KP, right? How do you set the speed of the robot moving forward? What is the forward speed of the robot? What does it depend on?
So the maximum speed is 6.28,
I know.
but for the actual speed, it's 0.75 into 6.28.
So you always move the robot at that speed and you only control the direction using the error, or what do you do?
No, sir. The depending upon the error value, it might go a bit slower around curves, sir, or other complex areas, sir.
Okay. So given that, uh, how would you try to move your robot in the shortest time from the start to the finish? Suppose there was only wall following.
Yes, sir.
What KP would you use?
Yes, sir. For that, I think you will have to use a suitable KP. Now that may change according to various circumstances, but you'll have a suitable KP for this, for to have the best time, because even if the motor speed is constant, let's say the motor speed is constant no matter what is the diversion, still robot moves in a zigzag path instead of moving in a straight path. It will take more time to reach its destination, right?
Okay.
If we have, coming back to your previous question, this is related to it. If you have a very high KP, then the robot will tend to move zigzag instead of going straight. And that way, the overall speed will be affected. Maybe not the motor speed, but then it will reach its destination later.
Okay, good, good. That's all. I just wanted to check your understanding. I have no other questions. Thank you.
Thank you, sir.
It's a nice work, but could you comment on if you had multiple code versions where you saw the total time vary? You understand what I'm saying? Did you see that, okay, you thought of adjusting KP value, or for example, looking at different set of sensor values, looking at error differently, looking at switching between the two controllers? Did you see a difference in the total time that the robot took from start to finish in your different versions of code?
Yes, ma'am. So depending upon the KP value that we had used, the amount of time spent to reach to the end would have varied a bit. So if the machine was a bit too sensitive, then the time would be decreased, because as my friend pointed out, it would zigzag in a path. So in order to get the epoch to the end as fast as possible, in our code, we had used actually 3 separate KP values. One for wall following in a straight line, one for curves during wall following, and a separate KP value for during line following, ma'am.
But is it only KP that affected total time, or did you see anything else, like the number of sensors you used, the conditions that you used, and so on? Or is it only KP?
Well, apart from KP, there isn't really aren't really any big factors that will change the amount of time taken to reach destination apart from KP, because motor speed is same. Then number of sensors, as you mentioned, a number of sensors will only give you a better idea of where you are in the arena, and maybe even the accuracy, but it may not necessarily change the speed. So I think KP value is the main factor here that will determine how much time it takes to reach the destination.
Okay. All right. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
So I have a question. You mentioned different KP values. First person to say this so far. I mean, how do you detect which part of the curve you are in?
It was we used the error value, and depending on the distance from the wall, we may use the OR condition to change the KP value. So
it was a function of the error value and the distance. Because you have 4 sensors you are using, right?
yes, sir.
So what is the meaning of a distance now with 4 sensors?
So there's a desired distance, sir, and then there's the actual distance, sir, that we calculate using the proximity sensors. So the error, we generate an error value by subtracting the actual distance with the desired distance, sir. And then depending upon the error value generated, the machine keeps adjusting its path accordingly, sir. So for this purpose, we found that the KP value would be for straight lines would be different for the most efficient KP value for a curved line, sir.
Okay. I don't have more questions.
Thank you. Thank you, team.
Thank you, sir.
So we'll move on to the next team. So it's team number 4029, Arna Maurya from Shraddha Mandir School, Panji, Goa.
My name is Zarna Moria from Team ID 4029. I study in class 7th in Shadamandir School, Goa. This is the task 5 output video. My code is divided into 4 main parts. The first is the simulation parameters, which are the time step and the max speed. Then the second is initializing the motors and sensors. The third is the behavior control flags. The wall follow is initially set to follow a wall. Line follow. Line following is disabled initially. Sharp left and sharp right are used to detect and handle sharp turns. The fourth is the main control loop, where the sensors are read and the logic for switching between the wall follow and line follow is implemented. By default, the robot is in wall follow mode. While in wall follow mode, a proportional controller is implemented. where the error is the difference between the left sensor distance and the right sensor distance. This will enable the robot to move in the middle of the path. The most challenging part is switching between the modes from wall follow to line follow. After multiple hits and trials, I observed that when the robot enters the tunnel, the two proximity sensor readings go to 0 and the middle ground sensor goes over the black line, giving values less than 40. Once the mode is detected using the behavior control flags, I switch to line follow. In line follow program, I am computing the error for proportional controller as right sensor minus left sensor. To increase the speed, I am using gain scheduling. In gain scheduling, I increase the robot's forward speed and decrease the gain if the absolute value of the error is less than 4. Otherwise, the KP remains at 0.2 and the velocity remains at 77% of the max speed. The second challenge is sharp turns. To detect the sharp turns, I use the logic where if the left and middle are on the black and the right is on the white, then it is a sharp left and vice versa. I reduce the speed to 5% on the sharp turns. The delta, which is computed from the proportional controller, is used to adjust the left and right wheel speeds. I use the saturation to avoid the burning of the motors. Thank you.
Interesting. So you have, what shall we say, sharp turn detection. But for the wall follower, how many sensors did you use?
No,
I use two sensors so that to keep the robot in the middle. Yes, so to keep the robot in the middle.
So in your case, apart from other people, consistently the robo, when making a curve, it was very close to the wall that was curving sharper and not the outer wall of the curve. For other people, I noticed that it would, in some cases, go closer to the outer wall of the curve, and in some cases, go to the inner wall of the curve. In your case, it was always consistent that wherever the curve is taking place, it will always be closer to the inner wall of the curve. Whether it is left or right didn't matter. Now, go ahead.
Sir, I don't really actually know, but I think it may be because of the saturation of the wheel speeds.
Because of the saturation of the wheel speeds. Okay, that's interesting. Okay. And did you time how long it takes for your entire run?
Yes, sir. It took about 3 minutes, sorry, 1 minute, 43 seconds.
1 minute, 43 seconds. Okay. And you chose not to use the other sensors. Any reason why?
Sir, it was because since two sensors were working for me instead of one, I used two sensors and not others. But using more sensors can increase the accuracy. I don't know about speed because the KP is mainly based for the speed.
Okay. Since you have heard the other candidate before you say something, you've been listening to that candidate, right?
Yes, sir.
So now that you know in hindsight what that person has done, so just as part of thinking out of the box, now if you had the opportunity to change KP value dynamically, would you do that? And therefore increase the speed with which you get to the destination?
Yes, sir. I would increase the speeds of. I would increase the KP, sir.
Using multiple sensors, I'm saying.
Yes, sir. Because it can increase. It can increase my speed and resulting in more time remaining.
Which grade are you in?
Sir, I'm in 7th.
You're in 7th. And where did you learn Python?
Sir, I learned bits and pieces of Python when I was doing Replit Python programming by myself. But I
Which grade
mostly
was
learned
that?
Python programming with e-Yantra.
Okay. And did any of your parents or your siblings help you?
Yes, sir. My father helped me.
In what way?
Sir, he explained me all the mathematics that was required for producing for
Okay.
helping me with the code for part tracing.
Okay. Okay. I don't have more questions.
What does your dad do?
So my dad works at the National Institute of Oceanography, Goa.
Okay. Raghu, you didn't ask that, so I thought I might as well ask.
Yeah, sure. I mean, in Goa, I mean, that's right. NIO is big organization in Goa.
If I can interject,
Yeah, Parito.
there were a few people before who have built an adaptive controller by adapting KP into different modes, right?
Right.
Yes.
But he's actually adapting the speed. Sometimes he's slowing down to 70% of the max speed, etc. And I think that was innovative part of this solution. So how did you fix those speeds, Arnav?
I fixed those. Sir, I use gain scheduling, where I decrease the gain and increase the forward speed. If the absolute value of the error was less than the 4, which I've kept there.
Right.
In the
But
code.
when you are moving on a straight path, when you are not, you are moving at a faster speed than when you are turning, right? Do you do that?
No, sir. As we can get outside the line.
Okay. Fine.
But sir, I also designed a system for that called the lost robot condition, where if all 3 line followers sensors go outside, go out on the white line, then if the robot keeps on spinning until it detects until one of the sensors detects the black line, and then using that I can start following the black line again.
So do you spin clockwise or anti-clockwise?
Sir, if it's for sharp left, then I turn on the left side, and if it's on sharp right, then I turn on the right side.
So you do turn in the right direction. Otherwise, you would wind up finding the line pointing the other way and go in the wrong direction.
Yes, sir.
All right, good. Okay, thank you. I have no further questions.
Good presentation. No other questions.
Thank you, ma'am.
Okay, ma'am. So we'll move on to the next team. So the next team is 2496 Ritusau from Dr. Shorambam Devagan Government Higher Secondary School, Chandigarh.
Actually, sir, I just want to correct this. Krishna Public School, Dunda.
Okay, you changed it. Fine.
Yes.
Namaste. I warmly welcome the jury panel to my presentation video of Task 5. Myself, Ritish Kumar Sahu. My registered ID is 2496 from Krishna Public School, Dunda, Raipur. So without any further delays, let's begin our Task 5 explanation. Over here you can see our Task 5, which is firstly the wall follower, then the line follower. And we have to transition between the wall follower and the line follower. So I am running the simulation and also explaining the code structure. Firstly, I have initialized the variables, the maximum speed and the kp, which is the proportional constant. Then also initialize the robot wheels and motors, after which I have initialized the PS6 sensor, which is the proximity sensor. Then also initialize the GS sensor, which is the ground sensor, 0, 1 and 2, and set the distance value to 100. In my while loop, I have gotten the value from the PS6 sensors, then the GS sensors, and stored them in the variables such as the right ground sensors and left ground sensors. Then I have calculated the error values for the wall follower and the line follower respectively, and calculated the average velocity and maximum speed for them. Also, I have calculated the left speed and the right speed of the motors, which converts it to unicycle mode. And my main transition lies in the if part. I have used the center ground sensor, which is the GS1 sensor. Using it, I have checked whether the ground sensor value is greater than 80 or not.
and if it's a greater than 80, then I am using the wall follower, and not which is it is less than 80, then it should follow the line follower code. So as you can see over here, it's completed its task.
All right, nice presentation. So, what were your challenges? Where did you fumble? Did you get it right at the first time?
No, ma'am. As usual, like I have gone through the trial and test methods to like figure out the KP value, and I have also given like checked many other possibilities of changing other values, such as dividing or multiplying or subtracting many values to other the wheels and all. So to get the perfect match for the turning and the um, transition. Like you can see in my right wheel speed, I have divided it by 0.2 to maintain a perfect distance from the wall while turning.
So, can you remind me what were the sensors and how many did you use in both the cases?
In the first, the wall sensor, I have only used the PS6 sensor, the proximity sensor, and in the line following, I have used the ground sensor 0, 1, and 2 sensor.
So,
Only
approximately
four
one
sensors.
or two during wall following.
Ma'am, to transition, I have used the sensor 1, ground sensor 1, and to maintain or to follow the line, I have used both the 0 and 2 sensors.
Can you say that again? For wall following, what was your criteria for changing speed? For did you have a how did you maintain the position?
Ma'am, for wall following, first of all, I have changed many, I have tried many KP values, and later on, I have also divided the right wheel speed with 0.2.
No, no, no. Can you start again? What were the number of sensors and how did you maintain the position and how did you?
In total, there are four sensors. The first one is PS6 sensor, the proximity sensor, which is used to follow the wall. Then the ground sensor 0, ground sensor 1, and ground sensor 2, which is used to follow the line.
So for wall following, it was only one proximity sensor.
Yeah, ma'am, I have used only one.
You did not use. There were others, right? Any reason why you used only one?
Ma'am,
Did you face any challenges with one? Is one sufficient?
Ma'am, I thought it one was sufficient because I am getting the error from only the left wall, as the sir mentioned. So I don't uh, think it's need for any other sensors, because changing values and getting the right values from the sensor, I thought it was uh, sufficient for that.
What about turns and stuff? You didn't see any challenges?
Yeah, ma'am, I faced challenge in the line following, where it has to take a 90-degree turn, but changing few values in the KP and dividing few other values, I got to like overcome that issue.
Okay, I don't have any other questions.
Parito, sir?
Yeah. So yeah, I agree that you can try with one sensor, but there are some assumptions here. What if you had a room and you were at a the right corner, where the wall comes up at a corner with a wall in the front and wall at the left? What would your controller do? Are you able to visualize the situation? Of course, in this exam arena, there was no such turn. But suppose you were moving your robot, in a room, it was following the left wall, and it came up at a corner where there is a wall in the front and there is also a wall at the left, what would you do? Or what would your robot do?
Sir, like I may use the right sensor, the PS1.
You are using only one sensor.
Yeah, sir. So like
So
according to
that's why, normal cars, they use multiple sensors
yeah, sir.
to also detect something in the front, what is the curvature of the turn, many things. Yeah. Okay. How did you optimize the speed of your robot? After all, you had to finish within shortest possible time, right?
Yeah, ma'am. Sorry, sir. I have like not given the average velocity for my wall follower. I have used only the maximum speed, but I have like decreased the values for making either right turn or the left turn. I have only decreased, not increased any of the values. Only I have used the average velocity, which is the maximum speed, into 0.75 in my line following, rather than I have used the maximum speed for the time consumption.
Okay. You're basically trying to move at maximum speed and just controlling the direction then.
Yeah, sir.
All right. Okay. I have no other questions. Maybe somebody else.
What grade are you in?
Sir, I am in 9th grade.
You're in 9th grade.
Yes.
And you've done any Python before this?
Yeah, sir, I have started Python learning on my own. Like I have first done the web development class from Whitehead Junior. Then later I got curious in the Python programming and stuff, so I just learned the Python basics with my own, on my own.
How long back?
I have started the web development in 2019, so around maybe in lockdown.
Wow. Okay, 2019. That's like 4th grade.
Yeah, sir.
Okay. And for this assignment, apart from e-Yantra team, did anybody else help?
Yeah, sir. In task one, there were many kinematics, so I got frustrated while learning. So my father actually helped me, like encouraged to try and understand by my own. Yeah, actually, he don't explain. He encouraged to learn, try understand such things. Yeah.
Okay, and what does he do?
Sir, he is in a government job in the. He is a pilot actually in a railway.
Okay. So, I mean, you're one of the first few to have done only one sensor-based solution, which Mr. Paritosh Pandya has been looking for.
Yes.
Okay. And I mean, yeah, you succeeded, but there could be corner conditions that you may not succeed.
Yes, sir. It may vary according to situation, right?
Okay. Do you know how long the whole traversal takes in your implementation from start to end? How long? How many minutes?
Sir, it's 1 minute 50 seconds.
1 minute 50 seconds. And while doing your KP trials, did it crash at any time?
Yeah, sir. Sometimes it rotates on its own axis. Sometimes crashes with the wall. Yeah.
So cases where it rotates on its own axis, what was the reason? Very high
The
KP?
KP values are very high actually.
Ah,
Yes.
okay. No further question.
Thank you, Ritesh. So we'll have the last member, the team number 5144, Sonakshi Chakote from Abhijay School, Thane.
Yes, sir. Sir, am I audible?
Yeah.
Yes.
Yes, thank you, sir.
Hello all. I am Sonakshi Sakate. My team ID is 5144 and I am in 7th grade from APJ School, Nerul. Welcome to this demonstration of Task 5. Here, the robot will perform a complex navigation task combining wall following and line following behaviors. This task is designed to test the robot's ability to move smoothly between two navigation strategies while maintaining accuracy and precision. In this video, I will explain the problem statement, the logic behind the solution, and the challenges I faced. This task starts with the robot following a wall. Once the wall ends, the robot must detect the line and switch to the line following behavior. This transition is difficult and requires the robot to handle the change in navigation dynamically. Also, the robot must navigate both sections without stopping or losing its path. A robot has multiple sensors to perform this task. For wall following, it uses proximity
Well, you
sensors
can
which
slow
are
it down a bit.
PS1, PS6 and PS7. These are used to maintain a consistent distance from the wall. For line following, our robot uses ground sensors which are GS0, GS1 and GS2. These are used to detect the line's contrasted color on the arena surface. Additionally, our motors are also programmed to control the speed and direction of the robot based on the sensor inputs. The robot starts with a wall following behavior. It uses the side proximity sensors to measure the distance from the wall. Based on this distance, a proportional control algorithm adjusts the speed of the wheels to keep the robot parallel to the wall. This ensures that the robot maintains a fixed distance from the wall regardless of any curves or bends. When the wall ends, the robot switches from wall following to line following mode. This transition is handled using a combination of proximity and ground sensors. The robot detects the absence of the wall using the proximity sensors. Simultaneously, it searches for the line using the ground sensor readings. If the center ground sensor detects the line, it aligns itself with the line and activates the line following logic. In the line following section, the robot uses its ground sensors to detect the line's position. It calculates the error based on the difference between the left and right ground sensor readings. A proportional control algorithm is then applied to adjust the speed of the wheels. This ensures that the robot stays centered on the line as it moves forward. One of the major challenges in this task is to ensure smooth transition between wall following and line following mode. If the robot doesn't detect the line after the wall ends, it may stop or deviate from the path. To address this, I implemented a search mode. In this, when no wall or line is detected, the robot rotates in circles till it locates the line. Then it switches to line following mode. Additionally, careful calibration of sensors and proportional control parameters ensure precise navigation. In this task, we successfully demonstrated the robot's ability to combine wall following and line following behaviors. This achievement showcases the power of sensor integration and precise control algorithms. Thank you.
Nice presentation, Sonakshi.
Thank you, ma'am.
Right. Can you talk a little bit about the transition from following to line following? And something has happened, right? Do you want to talk about that? Why?
Yes, ma'am. Actually, the transition part was a major challenge for me, and to implement the proper transition, I implemented a search mode. I thought of this by actually putting like, if I were in place of the robot, what would I do? So if I didn't find something, I would start searching for it. So I put in the search mode for that.
Okay, and the search mode, how does it affect the total time?
The search mode, does not affect the code, the full stimulation time much, but I think the KP value can be edited so that the epoch can move a bit faster.
Okay, now that you know how to do with search mode, do you think you would do it differently without the search mode?
I think search mode is a bit convenient than the if else logic and the other logics that we saw.
What if else logic do you mean instead of the search mode?
Like the flag logic and
the if else logic, and the if else logic, it took me, I also tried that. It took me a bit time for I needed to print all the values so that I know how when the robot has to change, and I should put the command. So think that took a bit more time than search mode.
So what was different between wall following and line following in terms of sensors?
In terms of sensors, the difference was that the search mode looked for the line as well as the wall simultaneously, and even if none of the wall or line is there, it would search for it, and when one of them is detected, it would switch to that particular mode.
Is the search mode always active, or does it come in only at certain?
Yes, if the robot doesn't detect a wall or a line, then it switches to search mode.
Okay. What grade are you in? I missed that.
Yes, ma'am. I'm in 7th grade.
Okay. Nice work.
Thank you, ma'am.
Yes, sir.
Yeah, so how many sensors did you use?
For the wall following part, I used proximity sensors. I used 3 proximity sensors, which are PS1, PS7, and PS6. And for the line following part, I used all the ground sensors, which are PS0, PS1, and PS2. Sorry, GS0, GS1, and GS2.
So for wall following, you use PS1 and 7 and 6.
Yes, sir.
So 7 and 6 are in the front, right?
Actually, 6 is in the left side. The 7th one is in the front, and the uh, PS1 is in the right side.
Okay, so one on the right side and then one on the left in the front and another straight ahead. Is that how it is?
Yes, sir.
So why this method? Why not symmetrically on both sides?
Sir, I use the third one to actually see if when the wall ends, how should I switch to line following. I use that for that also in the beginning. And I use that so that if I set a higher KP value, it shouldn't crash into a wall which is in front. And I used the sensors on the both sides, because if a wall is not present on one side, it will detect the wall on the other side, so it won't deviate a lot.
Do you know how much time your entire traversal took?
It is around 2 minutes 30 seconds, I guess.
Definitely more than 2 minutes, right?
Yes, sir.
Yeah, so what I noticed that your KP value is actually lower than what it should ideally be. I think
Yes,
you
sir.
are being very slow or very safe.
Yes, sir.
Why so?
Sir, because I tried a higher KP value, and it was deviating a bit too much from the path, so I set it to a bit less, so it won't deviate, and it would go in a proper line, and it would follow the wall properly.
Because I noticed it was taking a lot of time to react and turn around.
Yes, sir. Yes, sir. I would like to work on that further by adjusting the KP value more.
How many iterations of KP value did you try?
Uh, for KP value, actually, I was out of station at that time during the submission, so I didn't get to try much. But I still did it. 5, 6, I guess.
Okay. So when did you learn Python programming?
I was introduced to Python programming in the beginning of my 7th standard, but I started to do proper Python programming in this competition when this competition began.
Okay. Who else helped in this other than e-Yantra people?
Actually, in task 1, my mother helped because the mathematical operations and the functions were not in my syllabus right now, so I didn't know exactly how to work on that. So my mother helped in that.
Okay. Okay, I have no further questions.
Okay, sir. Thank you, sir.
Paritosh, sir?
Yeah, Sonakshi, nice project.
Thank you, sir.
Actually, I want to ask you one question. Which part of the project was the most fun?
The most fun part was actually the transition because I got to use my brain a lot and I got like something to think about and I could try different methods. So,
Right. You're the only one to have search mode there.
oh, yes, sir.
Okay. The other thing is, did you show this to your classmates and friends and something?
Actually, my classmates and friends are not that interested, but I showed this to one or two maybe.
Acha. Okay. Now let's analyze one situation. Since you've gone so far,
sir.
when you see somewhere while doing the line following, you had a rectangular 90-degree right turn or a 90-degree left turn.
Yes, sir.
And your robot managed to do, it managed to turn.
Yes,
But
sir.
what happens to the sensors as you come to the turn? What should see suppose your robot is perfectly aligned on the line so that the middle sensor is detecting the line, and then you hit the 90-degree turn. What will happen? So let's visualize and tell me what your control algorithm should do.
I think it should rotate in its like place
Why
if
should it rotate? It's currently showing error is 0, and then it hits the corner. At that point, what
so
does your algorithm logic say?
if suppose there is a 90-degree turn to the left side,
Yes.
most probably the left ground sensor might show some readings because there might be a straight line there.
Yeah.
So I think based on that, our robot could
Turn
turn.
left.
Yes.
Okay, so that is like, suppose your robot was a little fast.
Yes, sir.
You just managed to skip the line.
Okay.
Then what will happen?
Then it would implement the search mode again for this program which I have wrote right now. It would go in the search mode if
And it will
because
try to find the line.
yes, sir.
So search mode is quite useful.
Yes, sir.
All right, thank you. I have no further question, but nice solutions. So you see, when you design an engineering product, you have to think of all the ways in which it can fail and put some sort of handling of those failures, right?
Yes, sir.
Just design for one standard mode in which it will work. Reality is not so perfect since many things can fail, and you got to have defensive programming for that.
Yes, sir.
All right, good.
Thank you, sir.
Thank you, Sonakshi. So this is the end of our session 2. So we'll have a jury summary of the participants. Kavi sir, can you please?
Maybe I'll just say it at the end, but I think I'm surprised at the richness of this very simple problem. What seems like just wall following and then mode change and line following, just in this itself, due to the various sensors and the way people have interpreted the problem and come up with the solutions, it's shown a very rich solution space. So I'd like to invite each of our jury members here to give their impressions. Right? I'll start with Madhura first and then go to Raghu and Paritosh.
Was really nice. I'm very impressed with seventh graders thinking and solving and coming up with different solutions which are not always identical. Very impressed. I'm curious to see if we give them tougher problems, maybe they will solve them too.
We can only try.
Yeah, level 1, level 2 or something. Yeah.
Yeah. We can try chip design also. Okay. Raghu?
Well, yeah, so it's interesting to see that while students have taken help, they are not taken help for actually coming up with alternative solutions and workarounds and so on. They have taken more fundamental help and they have actually done this on their own. So that's encouraging. also interesting to see that people are learning Python at a very young age. Those who have interest have shown that they can spend time on these activities. But as the professor from KJ Somaya said, they also have to make sure that they spend time on physical development. Otherwise, we'll have challenges in later years that we'll not see today. Uh, I will come back on the question that you raised, and I want time for that. So I will stop here right now. Students have found interesting solutions. I mean, one sensor solution, four sensor solutions, particularly from the previous batch, the guy Vineet, right, from Mira School, Bengaluru. I mean, the way he explained his error calculation, that was outstanding. And the way he used the sensors to arrive at where he is in the wall following, his math was really good. So that was really, really good. And also the way he figured out how to use multiple values and iterate through them faster, right? So what he missed in the end, he said, I optimized for time, but he could have also optimized for cumulative error. Meaning, if he is supposed to be on path X and he computes the error and he figures out it is plus some left side, let's say is plus and right side is say minus, and he takes the absolute value of this error and keeps on adding these errors. And each run, he figures out how much was the total error totally. Then he might come with a smoother path and better KP values, and maybe he would have done dynamic KP values. So these are the things that I think if they were given some more guidance, they would have found the answers to this. Otherwise, to come on his own with multiple iterative values, use the error function in an intelligent way with the sensors in the front and the side, that's really good stuff. So yeah, so we have promised.
So how realistic and representative an engineering problem is this, according to you, Raghu?
This is good engineering problem. I would not downplay it at all because there are multiple factors. There's speed, there's doing the math, doing the proportionality calculations. All these are real life challenges. I mean, so let's hear the other jury because you asked this question about AI, and I want to combine all of this into one answer. So let's go out and come back.
I think Vineet has raised his hand. We'll just respond to that, and then we'll
Yeah,
move.
so about what sir said, that's what I tried doing. Like what you said is like the integral part of PID controller, the I part. So I tried doing it, but I didn't have the time, and I thought it'd be a bit too more. They thought P. So I did discover part of it, PID controller, and yeah, it will be way more smoother. So I tried it, but thought it would be too much. So
Okay. Take some time even now and do it post.
yeah, I still continue the project.
Yeah.
Thanks. So we'll move to Professor Paritosh here, if he's here still.
Yeah, I'm
Yeah,
here.
Paritosh.
Yeah,
And then
sorry.
we'll let Raghu have the last word.
No, you should have the last word. But no, I'm totally overwhelmed. I mean, students from seventh grade, building something of this complexity, and something that works. All of them had solutions where the runs finished. So I mean, I think they definitely are very talented, and congratulations to all of them. At the same time, I think e-Yantra has also found something unique, to bring them to this level of success. And I think there is something very positive. Many different skills go into, the students producing, an artifact of this kind, right? They would have to master many skills, including, a certain amount, having a certain amount of attitude to persevere and to solve the problems, not to get discouraged when things don't work, to go and search for solutions. We had mentors, but mentors only can give you, directions periodically. You have to have that fortitude to go ahead and keep on and build the solution. You have to manage your time. You have to have the interest. So I think one of the most important, attributes is that this competition is nurturing those abilities and also building a certain profile among students, which is very good. So I think all the finalists who came here can consider themselves as winners, and they've done very well. Also, I'm amazed at the breadth of different ideas that they explored. Some people explored the idea of adapting the KP constant depending on the situation. In the idea, they were sort of intuitively going towards what we call multimodal and adaptive control, where the control laws change based on the mode in which you are. So some others adapted the speed and not the constant KP, so that when you are probably going on the straight path, you can move much faster, with higher KP, make the robot much more reactive without worrying about it colliding. Some people did sensor fusion, using multiple sensors and integrating the information across those sensors in order to do a better control. And what we can sensitize them to is the fact that this intuition that they have found in putting together this solution has principles behind them, and as they go towards higher studies, they will learn the mathematics, which will allow them to use these ideas in a much more precise and a controlled way. So I think this is just beginning of journey for them, and I'm really overwhelmed with the, I would say, breadth and depth of what the students have explored without really knowing all the science behind it.
Yeah, Paritosh, well said.
Yeah, thank you.
But I'd like Raghu to give his bit now, because he wishes to kind of sum up what the essence of being an engineer is, and then I'll say my bit
No,
at the
no,
end.
no. So, Kavi, I just wanted, it was about AI, right? I think we have to be cautious about how we discuss, shall we say, the topic of AI itself. So, one is there is AI that's already available in various implementations and use of the foundation that has been built by somebody else. And there is AI that we have to do at a foundational level. And by that, I mean, are we doing the math behind it? Are we finding better algorithms, better ways to train, better ways to infer, better ways to distill knowledge out of what is available from multimodal inputs and all of that? And today, unfortunately, a lot of AI that's being discussed in the country, in our country particularly, is the use of AI that's already there. And if we want to make our school students chat GPT operators, I don't want to go there. What we should be looking at is how do we train these kids to do more foundational work. I mean, if you take today the top scientists in AI, more than 50% are from China. More than 50%. And everybody's shocked with DeepSeek today. But if you look at papers that they have been publishing in the last 5 years, they have been publishing very high quality papers in the last 5 years. Nobody has seen them. They are available in full public gaze, but everybody woke up only when they saw the results. Are we publishing papers of that quality? Are we doing similar work? That's the question we have to ask ourselves. So otherwise, I will just write on top of ChatGPT. And it's not that we should not write on top of ChatGPT some applications, but we will then be forever dependent on other countries' work. That's the fear I have. So I don't want to say AI is something that we can now use and make our AI better and so on. We have a long way to go. We are strapped by resources, we are strapped, but so were they. and they have figured out, for example, we do have 10,000 GPUs right now readily available in Panvel, Hiranandani, Shakti, Yota have that. What are we doing with that? Why didn't DeepSeek come from here? And we have had the Shakti Yota 10,000 GPU cluster for the last 2 years that I've heard of. So it's not that access has not been there, but it's that did we dig deep enough? Did we find why there is constraint? What are the real constraints? And have we been reading papers that others have been publishing, and are we reading at that grade? Are we writing at that grade? That's the thought I want to leave behind.
That's an important point. In fact, what I wanted to have a conversation with Partha was what is the foundational AI stuff that we can get youngsters acquainted with, right? At this age. I'm not very clear about it, but that's a conversation that we need to have. And you're quite right.
But is that the right expectation also?
That's
do we not need to have them to have the math background for that? And that math background is non-trivial.
Absolutely.
So I think we should first focus on getting the math foundation right. Some of the matrix operations that these guys have done is just mind-blowing.
So is there some way that we can experientially then train them in the math background which is required for these kind of things, even give them a clue of the statistical thinking that needs to go behind these kind of systems? Can we...
Professor Arya, I want to ask why target the kids first? We have to target the teachers. I will go there first. We are jumping too far ahead.
Actually not, because I see everybody as a learner. In fact, this whole thing about school and college and all that, I see that as a continuum. And in e-Yantra, we've also seen that the same way that we train older kids at college can be used with school children to great effect.
So out of the million kids, surely there will be a few. We should figure out how to get them encouraged and pull them out and give them better opportunities. But I don't know how to go about doing that. And it's really a hard problem that we can reach out to, let's say, 10, 20 million kids and figure out who amongst these can actually take up the math that is needed, right? And who can further the math domain that is required for this. That's a big problem. I don't know how to go about doing this at scale. But what I do know is we do need to scale our teaching skills and the teaching community to step up and be able to communicate these problems and distill these challenges to the students.
Fine. My response to that is that what we are doing, essentially, I am on Apex Higher Education Council of Jammu and Kashmir. And we've been tasked with installing 30 e-Yantra labs, 15 in Jammu and 15 in Kashmir. I'm also chairing a committee which is tasked with creating an NEP 2020 implementation manual. And essentially what we are trying to do there is see how all the subjects that we teach can be taught in a more experiential way. The message is very simple. It's just that don't just treat it like a textbook and assignments at the end. Get the real world into the classroom. And I feel that this can be done not only in college, it can be done in school also. That everything that you do in school is tied to the real world. And that's what...
Oh, absolutely. So there's no doubt, no two ways about it. What's being done is a must do. We have talked about it, and this is definitely on. I'm just commenting on the AI aspect of this. So the AI aspect, I want to keep, not trivialize it. It's a little more challenging than what we are thinking, and we have a bigger problem to solve.
Yes, yes. So that let that be the start of a conversation. I wonder if Madhura has anything to say about that.
No, just a minor comment about teaching the teachers and teaching the students, right? I mean, it's somehow, I would pick the students, they are faster for whatever reason, and they are open to learning. So No baggage that they carry, right? So
Yeah, let's not tell the students this. But anyway, thanks for the remarks. That's been our experience also, if you like. And the presence of all these youngsters here who welcomed this form of training with open arms, right? And not realizing that in the process they've learned some very valuable skills. Not only have they learned technical skills, they've learned critical thinking skills, which are absolutely core skills. They've learned problem solving skills. They've been sensitized, hopefully, with this interaction on how a good engineer works. So how any good problem solver works, that you don't just put any first idea that comes in your head down. You think of 10 different ways of solving a problem and then figure out a way to choose which is the best way of doing it. And that's what makes a great engineer or a problem solver or an IAS officer or an administrator or an entrepreneur, if you like. That's a very core skill. Think of 10 different ways of doing something and then justify which is how to arrive at the best way of doing it. And that's what the world really respects. Whether you are an entrepreneur, an officer of any kind, or engineer or scientist or whatever. So just keep this in mind. And what we are doing at e-Yantra is trying to build the systems with which we can train large numbers of young people in these skills. And that's what we've been doing here. So without much ado, now I'd like to hand it over to the next stage. We'd like to have the valedictory where we give the awards, and our team will do that. And then after that, we have a vote of thanks by Ashish. Right? What do I
Yes,
tell?
sir. Yes, sir.
Yeah, Prem Kumar.
Hi everyone. Before even starting, I would like to appreciate all the finalists because you are all very special. You are all very consistent throughout this competition, and you spend good amount of time in completing all the tasks to coming to this finale. We really appreciate all your efforts. Now we will move on to the most awaited valedictory ceremony of e-Yantra Intrepid Explorer Edition 2. So right now, based on overall submission score in each task and the judges evaluation, right now we have top 5 teams, and along with that, we are going to give one more category award. So right now, I'll share my screen.
But we'll also add that everybody who's come here is a winner.
Yeah.
Everybody who's participated is also very important.
Okay, I hope my screen is visible to everyone, right?
Yes.
Okay. Yeah, first we will start with the 5th. Sorry. Yeah, first the 5th prize of this Intrepid Explorer competition is Vidyaniketan Convent School. The teammates are Vaishnavi Banditkar and Viraj Vinod Ansulkar. Give them a big round of applause.
Thank you so much, sir. Thank you.
Okay. Then we will move on to the 4th prize. The 4th prize goes to individual participants, Sudhanva Kandur from the BGS Public School, Bangalore. Nice work, Sudhanva. Then we will move on to the 3rd prize of this competition. The 3rd prize goes to a team Meridian Riders, Varun Reddy, Pranav Reddy, and Vihan. The Gaudium School, Sangareddy.
Thank you, sir.
Yeah. And the 2nd prize of this competition goes to the team Tushar Vivek is an individual participant from National Public School, Bangalore. Nice work, Tushar. And the 1st prize of this competition goes to individual participant Kasvi Jain from the GD Goenka Public School, Jammu. And we have one more thing like Judges Choice Award. You probably know who is the winner for this particular category. Absolutely, that is Vinith Bojnavar, St. Mira's High School, Bangalore.
Thank you, sir. Thank you, e-Yantra.
Yeah, once again, give them a big round of applause for all the winners of this Intrepid Explorer Edition 2 competition. And also, this is the jury members that we got. Like, thanks to all. And this is the entire team that we are running this show. Yeah, that's it. Over to Ashish for vote of thanks.
Okay. So we'll conclude our whole session, and we thank everybody. We thank our participants. It's been it is a long time. Like, we started at 2 o'clock and now it's 6. So it's too long, but then we enjoyed throughout. So like the jury interaction, even the participants interaction, everything, it was very nice. So congratulations to the winners of Intrepid Explorer Edition 2. We see the happy faces and we are also happy with it. So congratulations to all, and all those who have qualified to the finals as well. And we thank our jury members, Professor Paritosh, Dr. Madhura, Professor Parthe, and Raghunath sir, for your valuable impression, and also the interaction. Like, it is just not limited to the theme, but also the students have explored more out of it. So we see that students are curious to try more in VBOT simulator. So that's the encouragement that you have given to the participants, and we see that they will do more in this particular domain. We thank Professor Kaviarya for always supporting us and guiding us throughout the competition. And sir has been like, he's guiding us to do more in school, to do this kind of competition. We have a virtual museum competition also, which is very distinct from this robotics and embedded system, which is again popular like this. So thank you, Kavi sir, for your support. We thank our team development team. So we have Agnel, Karan, and Ashish, Sukumar, and Prem, who have been continuously working on task development web. Prem was mainly handling the web part, and Agnel and Ashish throughout the competition, task development, mentorship, everything. So thank you, team. And we thank our media team, Riddhi ma'am and Anuj sir, for taking beautiful insights, stories, and consolidated videos. So after this, we will just play one impression video of our participants who have shared their experience. And yeah, thank you to Ministry of Education and for supporting us. And everybody, again, thanks a lot for your time. It's more than 3 hours, so thank you. Thanks a lot. Yes, Kavi sir,
I would like to
any?
say something here. I think I really appreciate the effort and time that Raghunath Iyer has given, and Madhura and Paritosh and Partha. They are very busy people, and it's gratifying that they consider the work that we do important enough to spend this kind of time on it. So Raghu, I really appreciate it. And the beauty is that without any hesitation, when we ask him, I mean, he's there, and that makes a huge difference. It gives us a feeling that what we are doing is relevant and important. And so with Madhura and Paritosh is actually part of our work, and so is Dr. Shubha, who you met earlier. Partha is a new faculty at IIT Bombay, and we are trying to get him involved. But I would like Raghu to have a last word, and then we'll go into the next that video that.
No last words. I mean, you're saying you're making me feel embarrassed. It's just nice to see the students do all this, and definitely, I few minutes back I was just thinking, when I was a kid, we used to do projects with what was called a mechano set. I don't know how many people today know what a mechano set is. Mechano set predates Lego blocks. Those are all sheet metal parts that you had rods and strips with holes and plates and all that, and you assembled things and you made robos, of course, they could not move. Then those gave way to Legos. And Legos, of course, you have a huge range of Legos. And today you have digital versions that are taking over. And it's glad to see that all these kids are doing this. So clearly there is some section of students who find these interesting. We would like to have more because that's the need. If we have to see 50 years down the line, these are the kids who will be leading the brigade. So they should be better armed and they should have more opportunities. That's all.
Thank you. And I just like to say that I found each and every one of the presentations today quite gratifying and exciting and meaningful. And I'd like.
No, I'm happy to see that they're able to stand up on a web call like this and
absolutely
do direct answers, right?
Absolutely. So
they're not prepared answers, right?
Absolutely, absolutely. And a big pat on your back, all of you.
Yeah.
Having done a great job. Thank you. And over to you, Agner or Prem. And the team behind the scene, Deepa's managing the school show, and we have Ajit Harpude who's here in the background. He's the administrative in charge of e-Yantra, who makes sure that all these things work, right? And then we've already introduced the team here. So over to you.
Yes, sir. Like I think we can have a group photo, like everyone of.
Yeah, we can have a group photo.
Yeah, turn on their cameras, like. Yeah. Still few of you. Yeah, nice. Okay. Okay.
Okay.
Thank you.
Thank you. So we can play the video, whatever it is. Thank you very much. Good night and Jai Hind, everyone.
Thank you, sir.
Bye and thank you, sir.
One final video on impression.
I also saw this e-Yantra competition very difficult for me. As I started doing it, I felt it was easier and I then said to myself, like, I can really do it. It's not so difficult.
Every time we tried, like we failed many times. This competition taught us resilience.
To see that whatever we've learned in this competition actually came in our math exam was kind of surprising, and it motivated us to try harder and learn more.
Before, I was not so good with time management. I had to manage e-Yantra with my school and table tennis classes, drum classes. I used to do anything at any time. After I joined e-Yantra, the tasks had a deadline, so I had to plan my time well to complete it before the deadline. Now I can do it easily.
Although I used to systematically study before and do all of my extracurriculars systematically, but I didn't necessarily plan it out as efficiently that I'm doing right now.
In other competitions, they sort of dump all the information into you, and after like a month or so, they just keep a challenge and then that's finished. In e-Yantra, they systematically segregate the information and then give it in a student-friendly way so that we can understand and we can cope up with our studies.
In this competition, we are greatly able to contact the mentors, and we feel like more like friends with the mentors than as mentors.
I needed push from someone to do this stuff, sit for your studies and all, but I don't need to be told anymore. I used to sit for e-Yantra, my school, on my own.
I fear to think out of the box. If these steps are given, I used to do the same steps, but in this competition, it was odd for me to think out of the box.
My confidence level has certainly increased because in this competition, we had to upload videos and we also had to give voiceovers, so my courage increased in that. I was very shy, and now I can speak up in class and can participate in different things.
I was not much talkative and interactive before, and after all these competitions and all, I've learned to interact much fluently. The way I used to study before is that read the textbook, question answers, and then go to the examination answer. Now, when I see the question, I break down it, understand it in a way, relate it to textbook concepts, and frame my own answers.
My confidence to speak at this level is mostly because of the live sessions and the interactive sessions you conduct. I feel confident to speak openly with the mentors.
After task 1 and 2, my brother also started enjoying programming, and he got motivated to learn more about programming and coding.
We never expected it will be that level. First thing is breaking the barriers of distance, and it's very nice because it's very rare to get same thinking pattern people around you and get encouragement. Whatever, if you fall, if you don't know anything, there are teachers to teach you. He do not open up very easily, but he has seen that friends of his age and how they are asking question and how they are presenting themselves, and he has learned a lot through that. Like, as a parent, I'm very happy. So this is the best age to have a trial. Just give your kids chance, because that may create a new door of opportunity in their life. Who knows? We are not aware what are their areas of interest.
I have been taking him to other courses also. The interest was not coming from him from inside. I had to force him. But here he is calling me, okay, now the time has come, now I have to submit this, because he got very much interested. Especially I feel it is because of the engagement. When we do conversation with each other, he is more logical. He doesn't use it that, no, this is the way I want. Try to convince me based on certain logic. I think this is right because of so and so. That has changed a lot in him. Which was earlier, it used to be no matter what, you don't know much, I know it.
Entire competition essentially helped the three of us forge new memories. It helped us to learn about a lot of things that we never learned before.
It's about learning something and discovering my potential.
Some students, they hesitate to join the competition because they feel that I don't know robotics or I don't know programming. It's fine if you don't know any of these, because they teach you programming from the beginner level.
I have interest in space, but also at the same time I learned that I have a lot of interest in electronics and robotics. So that's why I want to become a avionics engineer. To get to the decision, e-Yantra played an important role, especially this theme.
Every class was not wasted. Some classes even went beyond 1 hour, but then that was fine because we were learning more.
When you are able to completely finish that, we'll be proud that we have completed something useful. Even if we didn't win the competition, I feel proud of doing these tasks. It was a memorable journey in my life, which I could never forget. So I feel that these kind of moments are more valuable in life. To collect these kind of moments in life, they should participate in competitions like this.
Thank you. Thank you, team. Thank you, participant. Thank you, Kavi sir.
Thank you very much. Good night and Jai Hind again. And thanks for joining us. And I'm certain that all our jury members who've been here, Madhura is still here, have been quite delighted by the performance of each and every one of you. And don't go by these prizes and things like that. The journey that you've been through and that you've come so far in, I think it's far more important. And as you go on, you'll realize this in life as you go along, that these kind of experiences really form you. And we would love to welcome you back in other such competitions. These competitions are actually a way of getting you guys to learn cool stuff. And I hope that you will tell your other friends to also take part. Sabka bhala hoga in the process. So thanks again. Madhura, you're still here, and that's a nice sign. Anything that you'd like to say? Because it's the first time that you have participated. And
Yeah.
we would like to hear from you.
No, really nice. I'm still looking at it and I'm checking why did I miss these deadlines. I'm going to, publicize this even more in my circles. It's a very good activity. I think kids should take up, especially to get over the inhibition of things are tough. Robotics is not for me. Science is not for me. All those kind of barriers that come up, self-imposed. Keep up the good work, kids.
Thanks. So all you guys have our blessings, right? So Good night and God bless. See you then. Bye.
Thank you, sir. Thank you all. We'll conclude here.
Thank you, sir.
Thank you, sir.
Bye and thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.